Hello everyone, hello. In this live stream, I'm gonna go over how to switch over from Unity to Unreal Engine. I'm not doing any face cam today. Oh, thank you for notifying me. I'm not doing any face cam. That's been that. But I'm gonna show you how to switch over from Unity to Unreal Engine and how to learn C++. I've seen a lot of comments and struggles with people who migrating basically from Unity to Unreal, and basically telling me that C++ is very hard and they don't know how to get started. So I want to do I was thinking doing a short video, but currently that's taking time, and I'm also doing university right now, so I don't have much time. So I thought it was a good idea to do a live stream in this sort of format, so I can do a long content video. So in this live stream, we will basically going through all the basic things about Unreal Engine and C++. I'm not sure how many parts of this live stream I'm gonna do. Thank you. I thought I'd turn off the notification, but apparently not. I don't get it. That you don't want to have a notification, but you still get a notification somehow. Turn. Can I? Yeah, I turn off. Sorry for that. So it's basically turn off, but somehow I'm still getting the notification. That's fun. Maybe it's different. No. Yeah, anyway, I'm not sure how to turn that off. Because I thought it was from Chrome, but Chrome is already turned off. Last one. Anyway, let's go over how to install Unreal Engine, shall we? So what we can do is go to Unreal Engine. So I'm going to search for Unreal Engine. Change to English. There we go. So over here we have Unreal Engine, the web page. You can install them from here, which will bring you to a Epic Game Launcher. So if you just excuse me 1 second. Can we have a fade? Yes. I should be more prepared, but whatever. Do fade. There we go. So I'm just gonna do a little bit thing here, just checking that what sensitive information is getting shown. Let's see here. I should have my idle background over here. Yeah, I need to sign in over here. And my credentials are wrong. Why is that? Oh yeah, okay. Let's do that one then. If you wait a second. Let's do that one. And it didn't bring the page. There we go. It's weird that Epic Games signs you out in the launcher. And I need to have my security code. Get that. Oh man. Sorry for the delay. And there we go. There we go. So Epic Game Launcher is launching now. Oh, they have updated the interface. Well, only for Epic Game like launcher, or basically like Epic Games store. I'm currently updating, so that's why it's taking a little bit by. There we go. So over here. So as you can see here, we have this, which is basically the launcher. So you can click over here to install. You choose a location to install. Basically, I have already okay, yeah. So basically, I have already installed Unreal Engine. However, it's not showing up because I'm using the GitHub version. So you can click over here and install it via GitHub. I will not show you how to install via GitHub because it's very complex, and I seek you to watch a video about them. I'm gonna see if I can find a video. Unreal Engine GitHub YouTube. One tip that you can do is do cite and semicolon like so. I believe it's supposed to work. Maybe it's youtube.com. There we go. So you get you can search for a term only for one side, which is cool. So over here we have, for example, the GitHub repository. Show you in video how to do that, and we have of course a commercial. But let's just wait for that. Oh man, this is, oh, I thought I had to wait 2 minutes for that. Okay, so we have, for example, this person who done a how to install it from GitHub. They use, oh my god, they use a tool for I believe it's called a GitHub desktop. Yeah, that's I just want to show off a video, and we have some bunch of us. So we also have this person which done he installs GitHub he installs Unreal Engine by Git, which is a terminal CLI command line, sorry. So you can install it via the terminal or the command line basically. So it's very handy. I've done like that. So this way you can sort of have everything done via the terminal if you want to update and install a feature and such other. Do keep in mind that the GitHub version will give you the raw version of Unreal Engine, so basically the full project size. I can show you if I open this up and go to program. Over here you can see here Unreal Engine is taken up. Last I checked, it was over 200 gigabytes. Well, roughly there. So that's why you need to keep in mind that if you want to use the raw version of Unreal Engine, that you're gonna get every single package that Unreal is bundled to, and that's gonna take a lot of space, which is not ideal. if you have limited storage, which I have, so that's a little bit from. I'm thinking of switching to Unreal Engine 3.0 or well 3.1 when release, but currently I'm using GitHub version. And the main reason that is, if you want to use GitHub, then you can modify the sorry, if you want to if you want to use the Unreal Engine in GitHub, this allows you to modify the source code, which is pretty handy if you want to fix a bug or you want to change some things that you personally want. So that's pretty handy. However, the cons is, look at this, it's extremely, if I can, this is, there we go. So this is at 214 gigabyte. That's a lot. That's more than like a video game. So keep that in mind that it's gonna be very, very, very big in size. I can't zoom in. Sorry, zoom out. There we go. So keep that in mind if you want to use GitHub. It allows you to modify the source code and read everything you want and fix on some bug in their engine. But the con is that it's going to be a very big size for sure. But anyway, after you have installed the engine, preferably the newest, and remember that if we click on this, cancel this, so we have these number. This is very important because 5 is the major, 3 is the minor, and 0 is the patch. So if Unreal Engine releases 5.3.1, that means it's a patch version, and likely they have fixed a lot of bug fixes. So I will highly recommend to avoid this version, but wait for 5.3.1 to get some stability. So that's one recommendation that you follow. But anyway, after you install a engine, whether it's GitHub or from this Epic Game Launcher, you can now make Unreal projects. So let's go with that, shall we? So I believe you can open Unreal Engine either from Epic Game Launcher, or you can go to my files. So I have a shortcut which is in Unreal Engine, so I can just click on that to open up sort of Unreal Engine exe file. And this is gonna take a couple minutes to load up, maybe even seconds. By the way, this music is from Lo-Fi Girl on Spotify, and it's the Synthwave playlist. So if you want to listen to that music, then highly recommend. It's quite chill music, and it's very perfect just to have a music to talk over. And increase some volume. Let's say over here. Perfect. Yeah, like I said, it's gonna take a while. So sorry for that. And one thing that I also want to share about is that you can go to this GitHub page, which is mine repo that I made. So you can go to Miss Robin official and guide dash Unreal Engine as a one word, and you will find this repo which has a ton of documentation on how to get started with Unreal Engine and C++. So you can basically follow. This has been made with conjunction with ChatGPT as an assistant on writing and formulating each sentence. So keep in mind that basically I wrote a basic outline, then I used ChatGPT to sort of make it more formal and better understanding, because I like to use some words that is very basic. And you know, basically I'm from Sweden, so I'm not native English speaker, but I'm very comfortable with English. However, I have some niches about using the language. For example, I was learning when I was learning English, I learned both the British version and the American version. So it's I have some, you know, some tendency to, for example, use British words or use American words. For example, growing up with GTA, I was using hood and trunk as words for cars. And then when I switch over to, well, not switch over, but when I was more influenced by the British world, I became more aware of their term and their words for example, hood, which is a bonnet, and trunk, which is, ooh, let's see, trunk would be, I forgot now. Trunk would be boot. There we go. So like that, I'm still using like a hood and trunk compared to bonnet and boot, but I'm still I'm using, for example, petrol versus gas in America. So it's a very fun the difference of English. Anyway, so I'm just want to say this. It's a very long documentation, and this documentation is allowed for tutorials and articles if you want to make an article or tutorial video based on this documentation. The reading time is 214 minutes, which is what is it, maybe 3 hours, something like that. It's a very long documentation, and it contains 27,000 words. I'm not sure if it includes the code as well. I'm using basically a program to scan the markdowns, and I believe it's ignoring images and such other things to count, but I'm not sure how accurate it is. But yeah, some estimated word count. Anyway, so in this documentation we have table of contents, and by the way, this documentation is intended to work on Unreal Engine 5.0 and upwards. So basically, if you're using Unreal Engine and 4 version, some of this code and documentation might not be accurate for that version. So keep that in mind, that everything in this documentation is upwards on this point. Anyway, so we have table of contents, we have cheat sheet, which is just images from different creators and people. So if you just want to look at some cheat sheets and have a reminder how to use some stuff, for example, what data type, what is the common blueprint classes. We go over here, we have some key shortcuts and key bindings. We have some cheat sheet for the performance to use some console commands. That's very handy. So you basically have a cheat sheet, which is nice. And if you look over here in the contents, table contents again, we have getting started with C++. We have some like sort of outline how to what C++ is and how to get started with. You have some tools to start your journey, the benefits and the drawbacks of using C++, and the summary of C++ and the programming world. Here's basically a long section of how to get started with C++ and sort of the programming world, how to use the different techniques and all that kind of stuff. You also have blueprint versus C++, obvious architecture, naming convention, prefix, variation, acronyms and synonyms, data types, which will I explain a lot over here. We have reflection, garbage collection, Unreal header tool, constructor, destructor, and initializer or initialization, soft versus hard reference, global functions, libraries, macros, assertion, delegates, UNG, modules, plugin, preprocessor, and then we have some deep dive on, for example, the best practices, keywords, performance optimization, math expression node, column function in editor side. We have some console commands, shortcuts, and common problem. Currently I've just added 2 because that is the basic common area you will find. And we have some helpful links and support and footnotes. So we can look at the common problem. So for example, we have, if you have this issue in Visual Studio or any other IDE, you will find this error, which you can find this article, which is by Microsoft. It basically showcase a sample of this, for example. So for example, if you have this error, then description is a semicolon may be missing. So you can look over here that in this when you're creating a class, you need a semicolon to at the end of the braces to define the class. So if you're missing that, then you will get this error. The basically resolution is that you add a semicolon at the end. And then you have this error, which is basically if you had not defined the variable before using it. I believe it's also functions and class and structs. I'm not sure if they are same error type or they are from or they have a different error code. But I believe it's the same concept, that you cannot use a function, class, struct, or variable if you not have defined beforehand. So for example, if I'm using a function, I'm declaring the function beneath, then it's really complain because I need to define a function above when I'm actually using it. So there's a lot of stuff here to keep in mind and stuff you can read. For example, you have a math expression node, which is in Blueprint. With that you can use a better understanding of math stuff, which is pretty handy. Yeah. So I highly recommend to read this documentation. Not only can you get a more deep dive on how Unreal Engine and C++ is working, but you can also learn more extensively at your own time, which is pretty nice. Now, if you are like me, then you will probably struggling to read. So I highly recommend, for example, tools to have this be read out loud, or just watch a video, which I'm gonna upload soon, or you can watch this live stream, which I'm just gonna go a little bit how to get started with Unreal Engine and C++. So yeah, we have the different data types. We can go over here. We have the abbreviations and acronyms and synonyms. And we have so this is what I was talking about. We have a huge checksum. If you open this up, we have now another type of contents, which is more in depth of how C++ is working and how to use this with as programming language. So that is very nice. So if you don't have a core knowledge of how to use a programming language, for example like C#, then this is a great way to start learning about C++ and the programming world. But if you have some core knowledge, you can just skip this section. Anyway, let's start off from the beginning then. So getting started with C++, like I said, in this documentation, I highly recommend that you take a short class on how to get started with C++. But basically C++ is statically typed, compiled, generally purpose programming language that offers a high level and low level feature. It was developed by Björn Stornstopp. I'm from Sweden, but I believe this person is from, well, this is the co-founder of C++, but I believe is from Denmark, so I don't know how to actually pronounce his name, but it's quite funny. But the first name I can pronounce, which is Bjarne, that's how you say in Swedish. Anyway, he worked at Bell Labs in 1979 as an enhancement to the C language. So basically C was developed, I don't know exactly when, but it was a very I'm not sure if it was popular language, but it was a very strong and big language at the time. So much so that Bjarne decided with his colleagues to start off and create another version of C, which is a more subset of C, and he called it C++ in 1983. So that was a big step for C++, and that's basically how long C++ has been. I believe I can actually look this up. Hey, just Gray. And we got this pop up again. Welcome to a live stream. Anyway, when was C++ created? C#. C# was created in 2000. So remember that C++ have been over, I believe it's 40. Let's actually do the math, because I believe it's anniversary, or well, celebration. So let's do this year minus 1983. So yeah, 40 years. God damn. So C++ has been in 40 years uses. So that's pretty nuts to think about. And my cat just joined me today. How much? I can't see because I have a stupid YouTube icon over here. So I can't see the comment you made. How much time it's been that you make C++? So basically, if you're asking how long I have been coding with C++, I started in 2020. It's so hard to say it like that. But anyway, so I started from there to learn C++. Then I finally made the switch from from Unity to Unreal back in 1 year ago. So basically the previous controversy, I switched from Unity to Unreal Engine. So it's been quite a journey, and as much as I'm new to C++, Sora, and have I wouldn't say new knowledge. I have some knowledge, but I'm still learning as well. So don't get me wrong that just because I'm comfortable with the language, I haven't learned everything. So you keep that in mind. So therefore, I highly recommend that anyone who's professional, that you can also post comments and help other people to get some knowledge of how to get started with Unreal Engine, because I won't say it's complex to learn Unreal Engine with C++. However, learning C++ without Unreal Engine can be very complex, because there's a lot of things to keep in mind. Unreal simplifies a lot of stuff, so that's why I'm highly recommend to, if you want to learn C++, that you use, for example, with Unreal Engine, because it's not very complex as you might think. But that's why I'm recommending. And it's a bit of like C#, in my opinion. So there's a lot of common things with C# and C++. Basically, C#, it has some syntax which is from the C family tree. So it's very similar in the syntax way of C++, compared to, for example, Python, JavaScript, I don't know, Rust, but many other languages is not the same as C or C# or C++. So keep that in mind. Also, one thing about C++ is that many languages are inheriting from C++. For example, I believe not necessarily inheriting, but more so on taking inspiration from either C++ or C. And for example, many programs and utilities and, for example, everyday tasks that you use are probably using C++. For example, the operating system of Windows, I'm not sure in Linux, I believe so. And I'm not sure about macOS, but I think also so. So keep in mind that everything that you use today is probably either C or C++. So that's also that's why the language has been for around a long time, and it's very complex, and I won't say hard to learn, because you can skip a lot of things to learn as a new beginner. But once you master all the techniques, it can be very overwhelming, let's say that. But anyway, I believe, wow, it's compiling shaders. It's been like 10 minutes, it's still not finished. Okay. I thought I was gonna open up Unreal Engine today, but probably not. So that's one downside. They have updated the shaders in this version, which is a little bit sad to see that it's taking so long to load. The way the previous version worked, that was like when you load a particular scene, you have to wait like 10 or 20 minutes to load a scene or level, sorry, because it was compiling the shaders. Now it's run out from the level into loading up or booting up Unreal Engine. So that's a little bit sad that it's taking this long to load. But anyway, let's continue with this documentation that I wrote. So the next section is integrating development environment, or IDE. I'm using Visual Studio, which is free for private person or like individual. If you're using a company or working at a company, you need to have a license, so keep that in mind. Then you have Visual Studio Code, which is a more lightweight IDE that you can use. Well, I'm not sure it's an IDE because it's more like, it's just a program that you can code in. So it's not, it doesn't have a lot of native support. It has some extension that you can basically turn into an IDE, but I don't think that it has a native support for all that kind of stuff. but it's also free and open source if you want to keep that in mind. Then you have Rider, which is IDE that costs and is developed by JetBrains, and this IDE is very popular amongst developers, both in Unreal Engine and Unity, because their tools for making for programming either in C# or C++ is very nice to have. Sadly, it costs, so I haven't been able to try it, but a lot of people that have tried it have recommended so far. So I also recommend that you use either this IDE. Visual Studio has getting updates to both Unreal Engine and C++, so it's slowly catching up. However, Rider is so far from the rest of Visual Studio. So if you want to have the best IDE, Rider is your choice. If you don't care but still want a free IDE, then Visual Studio, and then you have Visual Studio Code, which is, I must say, I recommend it. But if you just want to open up, for example, the source code of Unreal Engine, or just look at your own source code for the game, then you can just use this. Oh, we got this issue. Okay. And it closes itself down. That's nice. Oh man. I believe I installed a plugin, but the plugin seems to be missing somehow. Let's see. Because okay, fit mode could not be low pitches and show otherwise this project. Okay. Okay. Oh man. Let's see. I don't know how this works, because maybe I need to open this and so. Well, isn't this gonna just load the last project? Okay. That's interesting. So this just, can you stop popping up? Okay. So that's interesting. I forgot how I installed this. Is it on the config? No. So I installed some plugins to Unreal Engine, but I'm not sure how it detects this. Let's just do this. So I'm gonna go to binaries, open up Unreal Engine. I do it like this. Let's see if this works. And no, this, but like, okay, because it says this project, but I'm not started a project, so that's very interesting. People saying delete the intermediates, save and build directories. The intermediate, okay. But that's gonna take a long time, because it has to load everything back up again. And I can't seem to find the intermediate. Here we go. So that's gonna take a long time. I believe it's... Ooh, I'm not sure if I'm gonna delete that. The intermediate has The intermediate folder is at 31 gigabyte. But that's gonna take a long time to rebuild. Oh, I'm not sure if I'm gonna do that. But that's hard. That is, I believe the building time takes 2 hours to recompile the Unreal Engine source code. I'm not gonna do that. But it's very odd that is doing that. Well, I'm gonna try over here and delete the plugin I've installed. Let's just do that for 1 second. I think I can start up the Unreal Engine by Visual Studio. Okay. Okay. That's very odd. Now we have this issue. Okay. Now we have a bad pointer. That's nice. There we go. Yeah, that is weird. That is so weird that it couldn't like load certain plugins. Anyway, I digressed. Anyway, so once you have installed Unreal Engine and open this up, you can basically choose a game. So let's create a first person and just select C++. I believe, yeah, you have as a tooltip, it says over here if we use this. How do I assume which shortcut? Windows plus, okay. There we go. So if I over here, maybe it's a little bit hard to see. And I can't, yeah. It says note you can use add blueprints to a C++ project and C++ to a blueprint project later. So keep that in mind that if you initialize a blueprint project and then you want to switch over to C++, you can do so later on. And vice versa, that if you choose a C++ project, you have the option to still use blueprint. So that's very nice to have. You have also the target platform, which is desktop, quality, and you choose scalable, starter content, no, ray tracing, no. I'm gonna select the directory and then a project name, and I'm just gonna create this. So I'm gonna create a first person template. So let's click on that button, and this is gonna take a couple minutes to start up. So I will be right back. So boom. As we are waiting for that, we can continue with this documentation. And of course Visual Studio is opening up. And we get this. Okay, cool. A lot of issues today. And I mean, it has created a Visual Studio project. So that's nice. Then I can boot this up on Unreal Engine from Visual Studio. That's one recommendation that if you wanna have a clean slate when working with C++ and Unreal Engine, always boot up Unreal Engine from this menu. That's I don't recommend. So anyway, let's just continue this fast. So here are some tools when working with C++. You have Visual Assist, which is a extension. I believe it's in VS, so Visual Studio. And then you have Unreal Macro Generator, which is free and it's basically a macro generator or macro editor for Unreal Engine, and it uses C++. So that's very handy. It's free and is for Visual Studio as an extension. So let's just do a quick summary of the benefits and the drawbacks of using C++. The most benefit is high performance. Compared to Blueprint and C++, you can make a game without introducing C++ at all. However, you will come to some conclusion that it's much better to use in some scenario to use C++ than Blueprint. And keep in mind that the whole point with Blueprint and C++ is not to use only for the whole game, but rather mix them both. For example, the way it was intended to use is basically you have a C++ base class. For example, let's say a character, and then you create a Blueprint version of that character, and that Blueprint version is a player character. So you can, for example, in C++ code, call, for example, kill character, which will then trigger a Blueprint version of that player character. So that's very handy that you want to mix both Blueprint and C++. And you also can do, for example, more complex stuff in Blueprint than in C++, which is more I want to say more abstract ideas, but then you can also go down to more very fine detail in C++. The next step is integration with existing codebase. So if you have any previous codebase with C++, you can integrate. Keep that in mind that you can't use standard library in C++ with Unreal Engine. Unreal Engine has their own library and tools and classes and variables, data types. You need to keep that in mind. But you can sort of convert Unreal Engine C# code to Unity C# code to Unreal Engine C++ code. It's just a little bit different naming convention, structure, syntax, but the sort of foundation and the whole abstract idea will sort of basic be translated. I won't say easily, but if you have some knowledge about C++ and C#, then you can sort of find a way to convert from both engines, which is very nice. With C++, you also have low level functionality. So for example, you can not specifically in Unreal Engine, but you can access raw memory and do some memory management. Keep in mind that Unreal Engine has a garbage collection like Unity and C#. The only difference is that regular raw C++ code does not have a garbage collection. It's only Unreal Engine which supports garbage collection. Now, if you don't know what garbage collection, I highly recommend to read this article, which is a Wikipedia article. But this essentially garbage collection is basically if you allocate memory in your computer, for example, let's say game object, and let's say for example, let's say an example over here, you have a player and you have a zombie. If you the player kills a zombie, the zombie will be still lived in the memory. Even though you're not showing up the zombie in the game view, the memory has still been loaded in your RAM, computer RAM memory. So what the garbage collection is doing is basically looking at every memory that you have managed, or sorry, you can say managed, but more so you want to use allocated. When you have allocated, for example, the zombie into your RAM memory, you will then find this memory and check, do we use this memory block? For example, the zombie has been killed and the player is not checking if the zombie, we are not checking, the player is not checking whether we have killed a zombie. It's just executing a function to kill something. It doesn't know if it's zombie or is not a player or something else. It just know that it should kill or damage something, right? So basically, when the zombie dies, we have no reference to that memory location at all. So what the garbage collection is doing is checking, do we referencing this memory block? If not, then we delete this from our computer RAM memory. Now this is gonna take a lot of performance when the garbage collection kicks in. So what many people are recommending is that the garbage collection is not running, it's basically running a lot of times throughout the game. So it's not running once but throughout the game, because you don't want to have a huge amount of memory to collect, because that's gonna take a couple seconds or even minutes to remove. So most likely it's gonna run throughout some frames. And keep that in mind, if you have deallocated or remove a memory block, for example, let's say we have zombie and we kill the zombie, and the zombie doesn't reference anything anymore, so the memory block is not used in anything anywhere. So you think that a garbage collection is collecting the next frame. Well, it doesn't. The garbage collection runs not frame by frame, but for example maybe 10 frames and 5 frames. It basically is random when basically it's collecting. So keep that in mind, it's not consistent of that the memory block will now be deleted after this frame. So keep that in mind. So the way you want to do, if let's say you're checking if the zombie has been deleted, is just use Unreal Engine's functions, which will check the garbage collection if the memory block is deleted or not. So that's very very important to keep that in mind. Let's go over the drawbacks. The drawbacks is that C++ code is prone to more errors. For example, like I said before, if you're missing a semicolon, braces, or inaccurate syntax, it can be very difficult to understand what the problem is, and the errors is not very helpful as new beginners, because it has a very complex of saying errors compared to C#, and it's not very easy or fast, like very easy to understand what is the error is actually meaning. So keep that in mind that C++ code can be more error prone and taking a lot of time of just learning what the errors are and how you can fix it. C++ code with Unreal Engine is tied to the Unreal API, meaning if Unreal API changes throughout your code base, some stuff might break, or for example you get some obsolete or deprecation function. So keep that in mind that the code base can change whenever. So keep that in mind. And like I said before, requires more storage. So if you have a GitHub version, it will take more size, for example 200 gigabytes. Compared to regular Unreal Engine from the Epic Game Launcher, which will be roughly, I believe is maybe 40 or 50 gigabytes. Then if you want to have editor symbol for debug, which is symbols to use with C++. So if you have a crash report, it's very hard to determine what caused the error if you don't have this section or this extension to the Unreal Engine, because this allows you to see, oh, here is from the source code that the crash was I don't know how to say. Basically you can see what line code executed when the crash occurred, basically. So this is very important, but the downside is that it's going to take more storage for your computer. So keep that in mind, that if you want to work with Unreal Engine, have a lot of storage, because it's going to take a lot of storage. For example, some projects, just Unreal projects, can get to 50 to 60 gigabyte, depending on how you use some asset. And for example, you have, what's it called, Unreal Quixel. You have a Quixel to use some 3D modeling, something like model assets. So that can also get very big, especially if you want to have 4K textures and complex geometry. So basically, if you want to work around Unreal Engine, you gotta have a lot of storage. So keep that in mind. But anyway, without talking, let's start using Unreal Engine and C++. Not sure how this is gonna work. I'm just gonna see if I can start with Unreal Engine, because I have some issue before. Let's see. I hope I don't have to compile Unreal Engine from the source code, because that's gonna take a long time. We shouldn't. Yeah, so you can see over here we are just compiling. We are just compiling and stuff. Weird that this window is not perfect. Why can we not choose the 50? Oh yeah, you can see here is compiling our code. Do we have a shortcut for this? No. Oh yeah, so this by default, this doesn't update our project version. We need to go to Atari version, update this to 5.2. There we go. So currently I'm just compiling this project. I'm gonna explain later on, but I'm just gonna try to open Unreal Engine editor before I'm continuing on. There we go. And hopefully I can start Unreal Engine. don't know why I had to recompile again, but okay. Let's see if Unreal Engine starts. Wow, I spent 1 hour already. That's crazy. And then we go. So now we have Unreal Engine. It's a little bit weird that I can open up from the exe. Anyway, so over here we have Unreal Engine, and if you want to open Unreal Engine with C++, you go to Tools, then click on New Classes. Just gonna bring up this. If you can move this way. So over here we have Programming, New C++ classes, Refresh Visual Studio Project, Open Visual Studio. So I believe you can click on this to generate C++ project files if you're using Blueprint. And if you're using C++ project and you want to use Blueprint, then just go back to our content browser. Let's do a little bit bigger thumbnail. Okay. Now here we can just click on Blueprint over here. So basically, if you're using Unreal Engine, Blueprint is automatically integrated, so you don't have to install it afterwards. So if you want to either choose C++, you need to generate the project files over here. But if you have a Unreal Engine and you want to use Blueprint, just click on here, and you have Blueprint class, so you can click over here and create some classes with Blueprint basically. And if you want to create a new class with C++, you click on Tools, New C++ class, and over here you have some classes to create in C++. Now let's go about the architecture, because that is very important. Can I? Not sure how this tool is very helpful to understand. So basically, if you look over here, I wish this tool was extended further. That's a little bit so. So over here, the main base class is uObjectBase. Then we go to uObjectBase utility. Now those two classes you can basically ignore because it's just for Unreal Engine backend to, for example, just set up everything so that you have to you don't have to manage everything else. But then we have uObject, which is essentially object class in Unity. So everything that is that you uses is from uObject. That is basically the base class that you're gonna use throughout your code base. So uObject essentially is object, which is like this in Unity. So keep in mind that uObject is object, the Unity version. Then if you go down over here, now we have a lot of lines, but I believe in this section, I don't know where its line is. I have you. So also, if you don't, if you keep in mind, if we can't zoom in any further, but when a class start off with a U, essentially means that it's a U object that is inheriting from a U, inheriting from an object. So if you see over here, we have U level, U package, U interface, everything is inheriting from the object class. So keep that in mind. Oh, okay, here, over here. So if we go over here, we have another class which is very essential. It's called a actor. Now this class inherits from U object, but it sets another standard, a prefix of a. So everything that is inheriting from this class, which is an actor, everything has a prefix of a. So a HUD, a player, camera manager, a controller, a level, script, actor, and so on and so forth. Now, a actor or actor essentially is relative to a game object in Unity. So a actor is something you can instantiate in the game world. Now it doesn't have to be visible to the player to see. It's just something that can be spawned into the level, essentially. So for example, a controller is a object in the scene that basically essentially you can control the inputs. I'm sorry, it's very difficult to explain as the it's very difficult to explain sort of the simplest way. But essentially, the way Unreal is architecture, because remember Unreal Engine started, I believe, back in 1990s. So Unreal Engine has been for a long time, and I believe Unreal Engine started as a multiplayer game. So the whole architecture and framework is surrounded by the multiplayer framework, essentially. So a controller is something that you can control. So basically it receives player inputs, but it can also receive AI inputs. So both AI and the player can send inputs to a controller. So if you look down over here, we have a AI controller, a player controller. So this will receive player inputs, this will receive AI inputs, essentially. A controller controls a pawn. A pawn is something that you can possess. For example, a player, an AI, a vehicle, or something else. Basically, it's something you can possess. So for example, a pawn, a character inherits from a pawn. So basically you can control a character, or you can have an NPC, non-player character. So keep that in mind that a controller controls a pawn, and if you have a character is a pawn, therefore you can control a character. Just gonna see what's some more over here. And not really. Basically, this side you have some information about the whole game. Like I said before, the whole Unreal Engine architecture is surrounded by multiplayer stuff. So a game mode is specific to a game mode. For example, deathmatch, a free to what is it? Free to all, not free to play, but basically you can kill everybody, or you have team deathmatch, or some sort of game mode basically. And a game state is basically you can save all the players' information, for example the scoreboard or something like that. And then you have other game related stuff for multiplayer stuff. Not very important right now for a single player game, so just keep that in mind. Anyway, then we have over here, which is a uActor component, because this has a prefix of u, essentially is a uObject class. Well, it inherits from uObject class. This is essentially a component class, which is relative to Unity component class as well. So essentially, a actor is a game object. uActor component is a component. You can attach uActor component to a actor. Some of the famous uActor components is uMovement component. This component allows you to move with a character. So every a character has this uMovement component. I'm not sure if every a pawn has it, because for example a car might inheriting from a pawn, but it doesn't have a uMovement component, because for example you shouldn't really move as a humanoid movement component, but rather for example you should use some wheels and basically different mechanics for moving a vehicle. So basically a character has uMovement component attached to it. Another component based class is using component. That basically means that every component that inherits from this has a transform, essentially. So for example your camera component is a camera which has a transform because it's inheriting from your scene component. Then you have your primitive component, which has a U-shaped component underneath, and it has a box component, capsule component. This is basically the collision stuff. Then you have also your mesh component, which is inheriting from your primitive component, which has, for example, your static mesh and your skin mesh. And then on top of the your skin mesh, we have also your skeleton mesh. So essentially, if you want to have a asset, if you want to have something, a mesh in your scene, in your scene or level, use either your static mesh component or your skeleton mesh component. Your skeleton mesh component can be animated and rigged with the character. Your static mesh component is basically something you can display in your scene, but doesn't necessarily use animation or any rigging to be accessed. So keep that in mind. So that's basically the whole architecture. You can also go in depth with this architecture and see all kind of the branches. You have also some asset, your data asset, storing data like a scriptable object. You have your texture 2D, your media texture. You have some sound data asset, interface, your level, your world. Your world is basically the whole world. It's a little bit hard to explain, but basically when you start a Unreal Engine, when you run a Unreal Engine game, it creates a world for containing everything. Then inside this world, it creates a level that will essentially be everything that resounds this level. So for example, let's say we have a menu scene, and we have some UI attached to this U level. Once this U level has been unloaded, everything that is connected to this level will also be unloaded, unless if you told Unreal Engine to not to do that. So for example, U level contains every actor in that level. So for example, a character, a pawn, and all that kind of stuff. Then we also have GEngine, which is essentially if you run Unreal Engine inside an editor or a game instance. So that's something to keep in mind. And then you have subsystem, which is essentially let's say a single class system. So basically you can create a singleton that basically spawns a class at, I believe, I'm not sure if it's runtime, but basically either in the editor or in the game engine. And that will persist until the GEngine has been unloaded, which essentially means that if you close down your game, your GEngine will also be unloaded. But if you start, for example, a game or the editor, GEngine will persist until you shut down the application. So keep that in mind that GEngine will persist throughout the whole either the editor or the game instance, and you will persist when you have loaded basically the whole game, essentially. I'm not sure if you can be unloaded and loaded, not 100% sure. But you can also go over here and look at some comments that I made about it. So let's look at you will. I'm not sure if I made it. Here we go. Represent a single instance of a level on map. It contains all the acts. Okay, sorry. So okay. Okay, so I should update this comment because a little bit contradiction. But basically UL and U level is a little bit different, but they has sort of same concept, but a little bit different. And then we have U blueprint function library, which is basically a singleton was sort of a static class for having some static function that you can expose to blueprint, and C++, which is pretty handy and nifty. And then we also have a HUD, which is basically the head-up display. If you want to have some UI, then you can use this. And because this is has a prefix of A, essentially this will be spawned in the game level. So keep that in mind. So that's basically the whole Unreal Engine architecture. So basically you have sort of the same concept with Unity and Unreal Engine, and sort of you have your object, which is essentially object, and you have a actor, which is essentially game object, and you have your actor component, which is essentially components in Unity. So you have similar classes and sort of the mindset that you can do some stuff. Okay, so let's get started with Unreal Engine and C++. So let's create a class. Let's say we want to create a C++ class and we shouldn't have from a actor. So a actor is an object that can be placed or spawned into the world. For now we can call this my actor, that's fine. We have public and private. Keep that in mind that you want to separate public and private. You want to click here public, and this will add a for the header file and the source file. It basically will add a subdirectory for public and private. This is to keep separated. Now I'm gonna explain the difference between header and source file. But for now, we're gonna choose which module we want to use. So this is our main module. So I'm gonna create my project. And then over here we can create another subdirectory if we want to, but for now I'm just gonna choose the default. We can click on create, and this will basically create our C++ classes, and it will basically reinitialize both Unreal Engine editor and Visual Studio editor as well. Okay, so let's just go over here. This has bring up live coding. Live coding essentially means that you don't have to restart Unreal Engine in order to compile C++ code. This tool allows you to compile C++ code without basically closing down. So that's pretty handy. And you can access this in, you need to open a level, and you have this button which will recompile and reload the C++ classes. And you need to also, if you wanna so this is how you can enable this tool, which is called live coding. And also you have some settings on how to basically use this tool. But if you want to access this tool without going to the level and click on this button, you can press Ctrl Alt and I believe F11, and this will bring up live coding, and basically will compile all the changes. Currently we have 0 changes, so it will finish up very quickly, and it has done nothing. So that's basically the live coding. If you have edit something in C++, then you need to bring up live coding. It basically will compile the C++ code and generate all the files that Unreal Engine needs to have to access in Blueprint and sort of in the editor. So keep that in mind that you need to compile manually if you want to use this. But anyway, this is C++ with Unreal Engine. So let's go over. Oh my god. Let's go over about how to get started with this. So we have a header file, and we have a CPP file, or source file as it's called. The header file essentially just contains all the information about the class, and the source file contains the actual implementation of the header file, or basically the whole class. Now you might think, why are we doing this instead of like C# and Python, JavaScript and all those kind of language, which you just have one file? And that's a great question. Because C++ is very old, we use you might say an old technique. You might disagree and agree with this sort of system to split up the source file and the header file. But it's very performance wise for C++, because if we import another file, for example, let's say this file, which contains information about this class, a actor. If we open up this class over here, let's put up, you will essentially see all this kind of information. Now what happens in the background with C++ is that every time you use the import system, which is include, essentially it will take everything about here and just paste it over here, like so. So you can see here that we have 4,000 lines of code here that is gonna copy to this file over here. Now, if we would include also the source file, basically the functionality of that particular class, we're gonna have a lot of stuff in this file. That basically will increase the building time or the compilation time using when you're combining both the source contents and the header file. So what they have done over here is just split everything from header file and source file, so that you just copy the definition of a actor. So you can, for example, reference this class and this new class. But we are not copying every functionality or the source code. Sorry, the source file, essentially. So it's a little bit hard to explain, but basically, let's say we have an actor over here, and let's say yeah, over here. So you can see here, this function has a bunch of code to initialize the actor, right? If we just include this file, essentially what we're doing, if I can find this, we are just copying this definition and pasting over here. That's basically what we're doing. So when we're calling this function over here, I can't do that because this is private function. But let's say if I could call this, then it's just looking, then sort of C++ will compile this code fine, because we don't need to know in the header file how this body, the function body, is constructed. All we need to know is how this function has been declared in the header file. So this function can be called in the header file, but when we include in this CPP file on the source file, it will then figure out, okay, so we're calling this function, and then we need to copy the body, the function body, in order to not copy, but for example to call this function. Okay, so I'm not, I don't know if I'm explaining this very well. So let's just show an example later on. But yeah, so I'm gonna explain later on, because I'm not sure if I'm explaining this correct. But anyway, so this is basically the C++ syntax. You have a class, you have a semicolon after the class has been declared with the braces. You have a public, protected, and public, and for example private section over here, like so. So you don't use public and yada yada, you just use public, then a semicolon, not semicolon, colon, sorry. And this is I prefer this way because you can define more function under this category of public. So instead of just doing a public this and public that and public so on and so forth, you have a sort of a grouping system of using a accessor. For example, if it's protected, public, or private or whatever, right? So that's another syntax you need to be aware when going from C# to C++. That's basically it for the header file. Then we also have this, which I'm just gonna say that this is a protection system for the header file. Essentially, when we are copying, when we're including the header file, essentially it will copy and paste it over here. But let's say we are referencing this class with the header file, and let's say we're also including this actor in another file, and we're not gonna copy it twice, because let's say if I have another class and call this my new actor over here, and this is also referencing this header file, then I'm not gonna just copy it twice, because both my new actor is referencing this header file, and my actor is referencing this header file. Thus I'm also including this header file as well. So like so. And so to prevent copying header files twice, you use this preprocessor, which basically will check that if it has copied once, don't copy it twice. So it'll basically check if this class, for example my game framework, has been already used in my actor header file, which is this one, then we're not gonna copy this. That's basically how you can save compilation time and building time. So basically this is very important if you don't want to explode in the builder time, because this will prevent from duplication of certain header files. You don't need to copy all the contents again and so forth. Anyway, core minimal is a header file for basically every data type that Unreal Engine uses, and that's basically a header file which include other header files. So this is basically how you can access, for example, well, not over here, but we have some custom data types that is specific to Unreal Engine. So for example, uint32 or int32, and this is a data type that Unreal Engine has declared, which is declared in core minimal. If I remove this, then this will disappear. And one thing to note that Visual Studio is very slow to pick up on the changes, so it's gonna take a while before this is missing. We can also if we hold down control and click, we can also see the definition, and which is over here. And you don't need to understand everything that is happening. Basically Unreal Engine just create an aliasing for their data type, which is platform driven. So if you're using Windows, Mac, or I believe PlayStation and Xbox, this will be different, but we have an aliasing, so it will be consistent for every platform essentially. Anyway, then we have also this, which is just for Unreal Engine to generate some data type, or not data type, metadata for blueprints and the editor to keep track on. And then we have some macros. Macros essentially is just text replacement. So when you use a macro, you basically just replace this line of code to something else. And that is basically how Unreal Engine exposes a lot of stuff to Blueprint and their backend tools. Because a macro will essentially replace, let's say, the code. So it's similar to attributes with Unity. So for example, if I use CLI's attribute, you expose the data type, or sorry, the variable or the member to Unity editor. And that essentially is the same with macros. So you have macros to expose to Unreal Engine editor. So you can work with Blueprint from C++ to Blueprint. So essentially that is a very big part of Unreal. And that's also the big issue with Unreal Engine. That is, it has a lot of macros they need to keep in mind. And those macros is not defined in Visual Studio. So you can't really see well how to use those macros in a simple way. So that's why I'm recommended before. Still recommended. But as I said before, use this Unreal Macro Generator, which you can find in Visual Studio extension. It's a free extension that basically generates a whole macros basically Unreal Engine uses. So for example, if I want to expose a member, for example a variable to Unreal Engine editor and Blueprint, use uProperty. If I'm going to expose a function, uClass for class, uStruct for struct, enum for enum, uInterface and interface, so on and so forth. So that's pretty handy. And if you click on uProperty, you get a lot of essentially options how to expose them. So for example, in Blueprint, if we want to have, let's see, if we want to have the Blueprint variable read only, or we can also read and write to it. We can also see if we want to expose the variable to whatever the view you are in, or you want to have the view only when you instance. For example, when you spawn for example a player, you only want to have the variable to be shown off there when you have spawned the player in the scene, but not when you are configuring the player, or something like a prefab or something like that. There's other stuff. We also have a category. This is very commonly used if you want to have a variable on a specific category. And you can also have a subcategory. So let's say player subcategory, which you use a pipe to define that. So health over here. And we click on OK for accepting. And it essentially has generated a macro which has a meta tag, or I believe it's called specifier, which is category player pipe health. And that's basically how you can expose variables to the Unreal Engine editor. And let's say I'm gonna expose a function. Let's say kill, or let's say send message, for example. I use the function, the macro generator, so ufunction. If I want to make this function to be callable in Blueprint, I'll press this. If I want to use a function in C++, but I want to implement the function the function body inside blueprint, I click on this button. So this specifier will allow me to call the function in other blueprints, but this specifier tells me that I can implement the function body inside blueprint. And then you have this one, the native event, which essentially means that the blueprint cannot create the function body. Only this is basically a virtual override system. So basically, when you're working with let's say inheritance, no, it's called what was it called? If you just wait a second. Okay, there we go. So basically polymorphism. So it basically supports polymorphism. So the way it works that is that you can define a body function in C++, but you also have the option to overwrite the body function inside the blueprint. So for example, let's say I'm gonna have I have this function send message, and I'm gonna create this in C++. I can do so, but let's say I'm gonna overwrite how it's implemented in blueprint. I click on this. Now note that you can't have implement event and native event. You need to either choose one of each other. So either implementable event, which means that you can create this function in blueprint, or you can create this function in C++, but then override in blueprint later on. You have blueprint pure, which essentially means that you are not gonna have an execution pin, meaning that it's gonna just return a value, and I believe it also cache the value. Don't quote me on that, but essentially it's just returning a simple value. So you can choose this. Note that if you choose a blueprint pure, you don't need to have blueprint callable. Blueprint pure will also be callable, but you don't have to specify with this specifier. So essentially, you can call this function, but it don't have an execution pin, meaning that once you have called the function, you're just gonna get a return value. You can't do add a sort of, let's say if I'm getting health, basically I'm gonna show you over here blueprint pure how to use it, because it's a very simple thing to use. So for example, this action, I'm sending the messages, therefore I'm not returning anything. Oops, I meant to click on that. Oops. No, I was not meant to click on that either. How do I open this up in there? Yeah, there we go. So over here we have a function. We want to call this function, so this is going to be blueprint callable. Let's say I'm going to return a message. So let's say I'm going to return a message count. So get message count over here. Now this can be blueprint pure because we're just returning a value. We are not doing anything about them. But let's say I'm calling this function over here. Not that. Let's just do a little bit better structure. Like so. Now, when you're using blueprint pure and you're doing like this, This might be fine. However, I will not recommend how to use like this, because essentially what you're telling Blueprint and people using it, that you're essentially just gonna do returning something. So you're not gonna do more. You're not basically gonna call more function if it doesn't return a value. So for example, here I'm sending I'm calling a function which do something else. For example, calling an action. That's not the point of pure. Pure might be to do like this if you are having a return value from some message, like so. This is how you can use Blueprint Pure. If you want to have a if you want to call a function but also return a something, I would highly recommend to just use Blueprint Callable, because that's essentially it. I'm not sure if I'm describing this better either, better way, but essentially Blueprint Callable should send a message, so should be a function that you can call. Blueprint Pure is something that you can return something and shouldn't be complex. So it should only return something and not be complex as a regular function, essentially. So keep that in mind. Just gonna remove this one. Let's go back to this macro generator. So that's basically it. We have also called in editor, which is basically this function can be called in the editor side of Unreal Engine, which is pretty handy to use if you want to test something out. Then you also have a category over here, so we can say player, we have events over here. Press OK. And we have now this. So we have call in editor, we can call this function inside the editor. We have also a category, so will it be nicely organized for both Blueprint and the editor to be called on. So that's essentially how to use macros and expose everything to sort of Unreal Engine. So now we have the syntax, header, and all that kind of stuff. Let's go about how this a actor is structured, or my actor is structured. So same concept with Unity is applied over here with Unreal Engine, that in the constructor, basically when this class has been constructed, it will call this constructor. However, don't use this constructor to use, for example, something in runtime, or for example any calculations or any important stuff. You really want to use BeginPlay or other callbacks to initialize something. This is just to set up this particular class. So keep that in mind, that the same concept goes for Unity and Unreal Engine, that because both Unity and Unreal Engine instantiate classes in the editor side, and therefore if you instantiate something in the editor side, this will be triggered, and this might cause some issue later on in the runtime version. Because for example, let's say I open up a Blueprint version of which inheriting from this class. Once I open, this constructor will be called. If I close the class, basically close the editor, and reopen the editor, this constructor will be called again. So if you're doing something like a runtime stuff, example, let's say let's say I'm destroying this actor, so call destroy, destroy, like so. This will cause interference because our constructor has not been, our class has not been initialized, fully initialized, to call this function. So this will cause huge issue. So generally you want to use, for example, important stuff or like runtime stuff when so that the class has been initialized, fully initialized. So for example in the BeginPlay, this is called when the game starts or when spawn. So keep that in mind that the constructor is basically configuration function for configuring your actor or your object to be initialized in either editor or runtime stuff. So keep that in mind. The constructor, yep. So the constructor has a default implementation which is primarily tick. B can be tick, can never tick. This is a boolean, and this basically, well, is a uint8, but essentially acts like a boolean. It basically means that this actor or this game object can tick. If you don't want this game object or this actor to tick at all, you can disable it. And when you declare as false, this tick function will never be called. So then you can simply remove it. And remember, you also need to remove this from the header file as well. So that's very handy if you want to disable the tick at all, so you don't waste performance. And inside this, I believe it's struct or class, but inside of this struct, we have another couple of variables, which is b start with tick enable. And notice that every boolean starts with a b lowercase, and then you have the variable name afterwards. And that's essentially how Unreal Engine declares booleans variables. And then you also have a struct which has a prefix of f, and you have, for example, interface, which is either has a prefix of u or I for interface. So keep that in mind. And also keep that in mind that everything in C++, well, C++ doesn't, I don't know if they have a definition, but the Unreal Engine had a definition of using Pascal case, meaning everything starts with a uppercase system. So my actor, like so. So no camel case or no snake case, everything is Pascal case. So keep that in mind. So for example, delta time is spelled with uppercase T and uppercase T as well. Anyway, this start with tick enable allows you to disable tick. Disable the tick if the actor has been spawned or basically when the game starts. So that's very handy situation where you want to have the tick function, but when you have spawned the game object or the actor, you don't want to start the tick immediately. Maybe let's say we have another function over here, send message over here, and let's say we declare the function over here. So the way you declare a function in the CPP file is that you would say what data type it is, because this is a void, because we are not returning anything. It's gonna be void. Then we do the class name. Then we do colon. This basically brings out the whole class member stuff. So for example, if we have the constructor, the variables, the functions, all that kind of stuff. So over here we have send message, and then we simply declare as a regular function over here. Now let's say we're calling it as a message, and then we can go inside over here, Well, this doesn't really matter now because now the tick is disabled by default when this actor has been constructed. So to enable the tick again, what you want to do is called tick enable. Probably set tick enabled over here. Then we need to set this to true. So this will start the ticking or the update function and run everything again. So that's pretty handy if you, for example, want to disable tick at beginning or when the actor spawns, but later down road you wanna enable tick again. So that's pretty handy. Let's just remove everything again over here. Oops. Yeah, BeginPlay basically calls when the game starts or when the actor has been spawned. Super essentially means the base class. So in C# you can do base and call the base class function. That's essentially super in C++. Well, it's not. This is basically defined in the backend of this hedge, sort of the generated header file that Unreal has been generated. So this allows you to do call the base function before doing anything. And this is very important because if you want to execute a code before you call the base class, you can essentially put the code over here. Yeah. But if you want to execute a code that have been called after this base function, you put the code over here. So that is very important to keep in mind, that if you want to do something before base class has been called or something after, you choose over here. And essentially you need to call this base function if you want to have support for the other inheritance functionality. So basically this does some code to just check that everything is working fine. And that's basically the whole thing about a actor. We essentially completed. Now I would like to add a couple of things to note. So for example, I discovered recently that you don't need to have virtual over here when you have a function that is a virtual function that has been overridden, because C++ code will essentially remove this, and you will have this when you're calling a virtual function in the inheritance class, for example in this class, because we're calling BeginPlay from a actor class. So if we can find over here, let's see. Oh yeah, so the actor defines this class which can be called. This has a virtual, so we can overwrite this class. But because the base class has a virtual keyword, we don't need to use it. We only need to use the override keyword to essentially say, hey, we're about to overwrite whatever the function that a actor has been declared. So keep that in mind, that the virtual keyword doesn't need to exist. However, it's very good. I will not say good practice, but it's okay to have it, because essentially you tell other programmers, hey, this is a virtual function. But for me, I like to remove it, because this override keyword is also essentially saying that, hey, this is a virtual function that has been overridden. And that's one thing to keep in mind, that like it doesn't matter if you have virtual over here, because as long as the base clause has a virtual for this function declaration, then this override keyword is allowed, and therefore you can overwrite the contents of this function. One thing to note is that if we have BeginPlay, we have tick, but let's say when I have EndPlay, when either the a actor has or this actor had despawned or the game has shut down. So what I want to do is do void EndPlay, like so. Let's zoom out, zoom in a little bit. So EndPlay over here. Then we're gonna do const EndPlay reason. Then we're gonna do ampersand. I don't know we need this ampersand, but we're gonna have EndPlay reason over here, like so. Yeah, we need to specify the type. So the type, like so. So essentially, this macro is under namespace, which is very odd, because Unreal Engine doesn't really support namespace. Essentially, with Blueprint, if you don't do like this, and this is a very weird way to define enum. But if you use this syntax for defining enum, I believe it supports namespace. But if you use, for example, a actor or any UObject classes with namespace, it will not work. So keep that in mind, that namespace doesn't really work, because if you use a namespace, then this macros will not be defined because it's not from that namespace. So keep that in mind. But anyway, this enum tells about how the function has been called. For example, if we have destroyed this actor or this component, if we have transitioned to another level, if we stop playing the editor, if we had removed from the world, or we simply ask quit the application. So this is pretty handy if you want to see, oh well, how do we end this actor? Do we remove from the game, or do we exit the game, or whatever? So that's very that's one thing to keep in mind. And we have a const. Const basically means that you cannot edit this variable or this member or this parameter or whatever. Const essentially means that you cannot edit this member or this variable or parameter anywhere. So that's very, very important. Now, because this is a virtual function from a actor, we want to overwrite it. Essentially just call overwrite over here. Now we can go to this function declaration in the, well, I picked the wrong one. Let's go to a actor. Let's search for this. Let's do this. So over here we have the function declaration is a virtual function. It has the EndPlay, it has const, and it has the enum, and essentially this is what we are overriding the function. That's very important. We can create this function in our CPP file, so like so. And don't forget to call the base class. So EndPlay and EndPlay reason over here, like so. Very important. And there we go. So now we have those function. We have BeginPlay, we have EndPlay, and we have tick. I like to have my EndPlay over here. So essentially, this is where I can initialize some stuff. This is where I can update some stuff. And this is some stuff that I can check if this actor has been removed, or it has or the game has been quit, or something like that. It's very good to know. There's also another function that's very important for initializing some stuff, where you don't want to use a BeginPlay function. So we have let's disable this initialize. Whoops, initial. I'm not sure. I believe it's called post initial. There we go. So we have pre-initial components, post-initial components. These are also virtual functions, so you can override this as well. So this is called right before components are initialized, only during gameplay. And this is after the components has been initialized, so allow actors to initialize themselves on the C++ side after all of the components have been initialized, only called during the gameplay. So essentially, if you have a component on this actor, for example, let's say a audio component, a light component, a mesh component, a inventory component, whatever component you want. And if you want to initialize something after those components have been initialized, but you don't want to use gameplay, you can use this function. And I highly recommend using this function if you want to initialize something on this actor, for example. Don't forget to call the base function as well. So here you can initialize some stuff. So let's say we have a variable over here in 32 and call this health. And let's say we want to set the default health value. We can set it over here as 1000. Sure, that works fine. However, let's say this health is just going to be used at the runtime. And it doesn't make sense to set this at the editor as well, because this constructor will also be called in the editor. Essentially, we can call this in over here in our post initialize component. Or we can also use this in the BeginPlay. It doesn't really matter, because this is just some callbacks when to initialize some stuff if we want to. Yeah, I'm not sure if this is going to be called every time a actor has been spawned. Assuming not, so you're going to use BeginPlay for every new actor has been spawned. So if I spawn, for example, 2 of my actor, I believe only this will call once and this will call twice. Not sure, I'm not 100% sure, but something just to keep in mind, where to put some logic and all that kind of stuff. One thing you also want to know, let's say we want to have a runtime variable, and let's say we want to expose this runtime variable to our editor. So your property, read only and edit anyway. So we can edit our health variable in Blueprint. We can edit our health variable in our Unreal Engine editor, but in the Blueprint version we can't edit it. We can only read from it. So we mark this as read only. Now the problem is, because we are using new property, it will mark this as serialization. Basically, it will save this into a text file for the editor side to basically remember all that kind of stuff. And this can be problematically, because let's say we exit our editor and we restart the editor. Well, this variable will be saved to the editor or to the product files. But we don't care about this variable to save our disk. We only want to use this at runtime. I'm gonna, for example, set the health in the BeginPlay over here to be 1000. So we don't care about saving this to our disk because we can still set this into in our function. So the way you wanted to use this is use inside of view property called transient. Transient basically means that this view property or this variable will not save to disk. So therefore this will never be saved. Therefore when you restart the editor, this will be initialized to 0 or the default value of that data type. So keep that in mind that if you don't want to save something to the editor, just use transient, and this will be simply a runtime variable. So that's very handy. You also have meta tags for your property for basically controlling all that kind of stuff. So for example, we have over here we have a lot of stuff. We have umin and umax, and we have also display name, clamp min and clamp max. You might think of what is the difference between umin and clamp min. Clamp min basically means that in Blueprint it will be min and max, and in the editor this will also be min and max. But if you want to just if you just want to clamp something in the editor but not in the Blueprint, you use umin and umax. So that's very handy. If you want to clamp both in the editor and in Blueprint, use clamp min and max. If you just want to clamp something in the editor, use min and umax. So let's say I'm gonna clamp both in Blueprint and the editor. So I'm just gonna type in over here 0 and 1000. Now the default is a little bit the default implementation for this macro generator is a little bit weird, so you need to fix this up manually. Essentially I'm just gonna do like this. So the minimum value I want to be 1 and the maximum value should be 1000. You can also use a string in this case. I believe it works fine, but you can also do without strings as well. Note this is a meta tag, so it uses meta, and this basically means we have extra functionality for our macro definition or specifier. So for example here we can do display name. I can choose something over here, so layers layer example. So that is one thing to keep in mind, that you can extend a lot of stuff with this. Another cool feature is to use the meta tags for units. So you can define our mass, for example. Let's say our mass is going to be in kilos, like so. So now we know that this variable is in kilos, but you can also expose the units to Unreal and to Unreal editor. So let's create a U property. We're gonna have read only, edit anywhere, and we're gonna have inside our meta tags we have I don't believe this generator macro generator expose this meta tag, but essentially you add let's just remove this for now. So you do meta parenthesis, then units equals, and then double quotes or string, and then over here you can use the the units that this variable is referencing to. So for example, kilos, like so. Also, I believe you can do the full name, so kilograms, like so. And this will interpret the same way as doing kilos. You can look at up a person, which defines later on over here, called BenUI, which is a very popular person who does a lot of articles on Unreal Engine, and it basically shows you some like tips and tricks and UI and a lot of complex stuff, which is pretty handy. So I would recommend this. But if you search for U property, you can see all the different stuff about it. I believe it's Unreal Engine U property. Over here. There we go. So this basically exposes every single thing you can do with U property over here, which is pretty nice to have. So I highly recommend this if you wanna just skim through and check what the possibility you can have. But if we search for units over here, we have this, which is a meta tag when units over here. So over here, let's zoom in a little bit more. Okay. So for example, we have units in Celsius, kilograms, this space, so gigabytes, percentage, and time. You can see the different result over here. Now note that if you use a unit that is not metric, for example, let's say pounds. So let's say we're using mass in pounds. What will happen is that in the editor side, it will still represent as kilos, but it will convert the backend value to kilos at the front end. So for example, let's say I say mass in 30, which is in pounds. So this will be at pounds at the back end, but it will be converted. Let's see, 30 kilo. Let's do there we go. So essentially it will be to this at the front end. So even if you use a not metric value, this value will be converted into a metric value in the front end. So keep that in mind that while you can support different units, every time you use a different unit that is not metric, it will self convert to a metric value at the front end. So it will still be represented as kilos. So you gotta remember that. But at the front end, you can also type in, for example, in the editor, for example, 10 and pounds over here again. And this will self be converted, let's say 50 pounds for now. And this will be converted into this again at the front end. So you still have the options to type in a specific unit and will self convert to the metric unit that is going to be used. So that's one thing to keep in mind. But you can also look at the example and the source file. Yeah, if you want to look at the source file, you need to be registered to the GitHub repository, which is free. But basically, the source code is you can look at the source code, but basically the GitHub repo is private. So the source code is available, but it's not publicly shown, basically. But you have different units, and you can also force a unit yeah, I believe also you can force a unit to overwrite the default. So if we want to overwrite pounds instead of kilos, then you have this option. But essentially we have a lot of units. We have lumen, LM or lumen, like so. I believe locks we have, which is I believe like this. We have percentage, which is like this, and the multiplier, which is I believe x times. So we have a lot of stuff. We also have centimeters, like so, and centimeters per second, I believe so, and meters per second, like so. We have kilometer per hour, I believe also. Note that when using kilometer per hour, we'll then convert it into centimeter per second, which is going to be a large value, which is a little bit sad, but that's the default implementation. I believe you can override the default the force unit, so it will display kilometer per hour instead of centimeters at the front end. That's very handy to know. And I highly recommend to you check out BenUI, these articles, because there's a lot of stuff that I learned from here that you can basically expand and for example do a drop down, do a multi-line text and password field that you don't wanna share something, do an array, do a fixed array. Yeah, a lot of stuff you can basically do. For example, if you have a caller but you don't want to show the alpha, you have that tag for disabling that. There's a lot of stuff that you can do with the Unreal Engine's macros. So that's one thing to keep in mind. But let's say if we have done that, so let's say I want to just do some couple function. Let's say I want to take damage, so we can do public over here. The void take damage, and let's say we're gonna do random damage. So I'm gonna expose this to blueprint, and I also want to expose this to the editor, like so. I'm gonna generate this function and DPP file. Sometimes Visual Studio don't generate the definition, sometimes doesn't, sometimes it does, so keep that in mind that you need to make sure everything is linked up together. So let's say this, and let's say we're gonna have transient over here. Make sure that everything is spelled transient. Yeah. Let's say we're gonna change this to speed, and this is gonna be 80 km per hour, for example. We're gonna define, well, we have max health. Okay, so let's do int32, call this max health. We're gonna do view property. We're gonna have edit anywhere, read and write, like so. We're gonna have meta tag for this. Call player max health. Okay. You can do like max health player, something like that. Transient over here. Now, when you're using long-term variable, you don't want to expose this to be public because you don't want to modify other classes shouldn't modify this. So I'm like to use private section over here down at the bottom just to separate all this stuff. And also note that in C++ there's no support for properties or property. The same concept with sort of the C# version. So if I do for example, private int health over here, then do public int health over here, do health like so. C++ doesn't have support for property, and I can't do get and set to value, so I can't do like this, sadly. The way you need to do is by manually doing getter and setters. So for example, let's say I have a variable over here. Let's say I'm gonna get and set, then I need to expose. So let's say over here in the 32 get health like so. We essentially just return, and I'll come to expression body with C++. It's only a C# thing, so I need to do like this. So return and do, let's say, current health. So let's rename this variable like so. Now note that when we have a getter, that we don't want to modify this variable, so we can return const after the function I declare. This prevents the function to modify the variable, but it doesn't prevent when you call this function that this return value cannot be modified. If I have const over here, then the return value cannot be modified when you call the function. But in this scenario, and when I add a const after the function, it basically means that this function body cannot modify anything inside them. Let's say I'm modifying current health to be 100. I can't do that because this is a const function. So that's just a very good practice to just, if you want to have something const and not modify, then just use that. Then you can do your function and blueprint Q over here. Now note that I also like to use force inline, and this is quite I won't say complex topic, but basically when we call this function get health, let's say in tick function over here, what essentially this function to do if we remove this, so this function essentially is just returning a value. So we call this function, C++ need to know this function. So this function needs to store in our RAM memory in our computer, right? That is very bad because essentially we're just returning a value. And we're not doing anything about it. Like we are not modifying anything, we're just returning a value. So the C++ programmers or developers who made C++ figured out, well, this is very performance cost because we're calling a function to just return a value. That's not very good. So essentially, we remove this function and we essentially just paste the value over here directly. And this is force inline. Now inline over here, I don't believe I will have that, but inline over here basically tells the compiler basically how to export this function. So this function will now determine itself if we need to have this function to call over here, or if the compiler can replace this function by simply with this. So let's say I'm doing current health, let's say in 32, I'm doing new health, and we're doing 100. When we compile this code, C++ compiler can either tell, well, we're calling the function, and what we're doing with this function, well, we're just returning this variable. So we can replace the function by just doing this at compile time. Note that it's not doing that runtime, it's doing compile time, meaning it will strictly paste the variable directly. This saves performance. Because now this function doesn't need to be in memory. Now the problem is because we are using inline, the compiler basically manage whether it's going to be inline, basically replace the function with the actual return value, or if we need the function. Let's say we the compiler says, well, here we can replace the function with the variable, right? But let's say the next line which do something else that is more complex, and let's say the compiler just can't figure out this scenario, so it will keep this function as it is. Now that's problematic because now the function need to still be alive at the memory, in our RAM memory, because we need to call this function somehow. But this is very bad because in here we have replaced a function with a variable, but over here the C++ compiler can't tell whether to replace it or to just call the function. So therefore it's more recommended, if you want to replace everything, to use force inline, like so. Now to sum this double underscore then force inline can be a little bit disgusting to type out. So Unreal Engine have made a alias to type in force inline with the capital letters, which essentially is just a macro which will replace this text to this. So that is a very important macro. Sorry. So essentially, every time we call this function will be replaced with the return value, which is our return value is current health, will essentially be replaced like this. And this is how you can save on performance, because in a getter we only want to return a value, so we don't want to modify anything. And because we are returning the value, and let's say this value is private, well, we don't want to expose this to public, because now other classes can modify this. So we want a getter, but we don't want getter to copy everything, because remember, everything in C++ is a value type, meaning if you return this, we essentially just return a copy of everything, which also costs memory consumption. So with force inline, you essentially tell this memory location will be pasted at every time we call get health function, which is more memory performance. I also want to do another thing over here, which is void alter health over here. And let's say we want to do int health over here, so new health. I'm going to add an ampersand over here. Now note that everything, and I mean everything, is a value type in C++, which means that everything is a copy, which I'm going to explain in a couple of seconds. If we add an ampersand, that basically means that everything is a reference type. Now C# uses both value type and reference type. I believe in Python and JavaScript, I'm pretty sure Python uses everything as reference, and I'm not sure if JavaScript also uses everything as a reference type, which can be problematic as some scenario. Let's just do callable over here, like so, and let's create this function. So value type, if we declare let's say new health, no, let's say play health over here, and set it to 100. If I set a new variable called play health modified and set it to play health, essentially if I then do equal to 50, what happens is that play health will still be at 100, even though we have assign a new variable to our player health, because everything is a value type, meaning this will be copy, player health will be copied into this variable when initialized, right? Or assign, because we're using assign operation. But let's say I want to modify player health. I want to convert our variable from value type to a reference type. Then I'm going to add an ampersand, and that basically means that every time I modify this variable, essentially we are modifying this variable instead. This variable doesn't exist in the code because it's just going to take a memory location of this variable. So we haven't created a variable, but we're just referencing a variable. And this is a great way to, for example, if we want to modify something. So in this example, we are modifying an out variable. So let's say we are passing a variable, but we can also modify this variable. So let's say our new health is 100 or 69, for example. And let's say we're calling this function, take damage, and we say our health, current health. Because current health is a value type with no ampersand, we'll then pass this into our function. It will then convert into a value type, which reference type, which means we can now change this variable at any time. So if we say new health over here, we're essentially modifying this variable because this converts from value type into reference type. And now our variable over here is going to be 69, but before it was 1000. So like so. So this is a great way to do an out parameter in C++, because in C# you can call, for example, out int 32 like so. But in in C++ you can't do that. Only the way you do that is to do like a reference type, essentially. Now you also have a macro for Unreal Engine. And this is just to specify for the programmers to use it. Now I have some issue with using this in and out. I'm not sure if it's supposed to use in our header file or in our source file, but essentially just a helpful indication for the programmer, so it doesn't do anything different at all. It's just a text for the programmers to just see, oh, is it in variable or an out variable. But you can also do this with the name, so out new health, which is most programmers choice, because this also tests the blueprint. Hey, this is an out variable. But not only does the name tell you if there is in or out, but also blueprint by default, if you have a reference like this, we essentially do an out parameter by itself. If you want to have an in parameter but as a reference, you need to add a const over here. That basically means that it's not going to return as an out parameter, but we're just gonna have pass this variable as a reference. You note that. And when we use const with a reference over here, essentially that means that our variable has been converted from value type into reference type, but we added const, therefore we cannot change our variable. So this is a great way to save performance, because we are not copying memory, because if we try to do like this and we call the function with a variable, essentially current health we copy, because this is a value type, so like copy into this function. That can take some performance, so you can use a const reference in order to just use the memory location from this variable instead of just copying every time we're calling the function. Now in some function it doesn't really matter if you use const reference. For example, in tick function, it can sometimes hurt the performance to do like this, because essentially we're taking the variable delta time that has been called from the tick function. So for example, let's say in an example, we call them tick over here. Now we can't call, I don't believe you can call like this. No, we can. No, I'm not sure. No, because they call, okay. We try to do like this. I'm not sure, but basically when you have a reference you can't do a inline variable. You need to pass in a reference. So let's say auto health, let's just disable this code, and we have made this const, and let's say we try to call this, and let's say I'll do 100. No, okay, it works because this is a const, because we're passing as a reference. But if we remove const, meaning we need to pass a reference as an output parameter, for example, we can't do 100 because it needs to return something. So what we can do is just to do int32 over here, and let's say out health over here. Then we can pass this down, and then we can see if the value is, for example, is if the value has been set or changed or whatever. So that's the difference between value type and reference type. And like I said before, like adding const and a reference at anywhere doesn't really matter in example small data types like float, int32, boolean, like small stuff, variable, data types doesn't really matter. The only thing that matters is if you use a big data type, or like not a big data type but medium large data type. So for example, let's say I'm using color, f color over here on an f vector. F vector is basically vector 3. See if I open this up, which is a template of vector class. So we can use either float or double as the data type. Essentially, we have a struct that has an x and y and a z value, right? Meaning if we go back to our let's close that one. If we use f vector over here, just for example, f vector over here, let's comment this up. New have. We have okay. Yeah, so this doesn't work at all. Yeah. So we have x, y, and z. Now the x value, because the f vector in Unreal Engine, everything that starts with f is struct, right? But essentially by default the data type is double. If you also want to use float, which I wouldn't recommend in Unreal Engine, I will highly recommend just using those data types, because though this is specified by Unreal Engine which the data type the template should use if it float or double. But if you want to specify a float or double, you have to use f vector, then add a 3, then d for being is a vector 3. And if you want to use vector 2 and 4, you have to add d for double at the end. Same concept, but remove the d and add a f, let's say float. So if you just want to use a variable with a float, with a vector with a float as a data type, then just use this. So that's one thing to keep in mind. Now the f vector by default is the template by double. Now if you don't know the data type and sizes, essentially we do a comment over here. Float is 4 bytes in size. Well, in C++, the float, I don't know the float, but the int can be different sizes. So therefore it's recommended to use int32 as a data type instead of int, because int can either be int16 or 32, and sometimes int8, I believe. Different if you basically the difference is how large you can store values, and because if you use int, basically I believe C++ compiler will basically choose if it's int32, int16, int8, so the exact size of int can differ in many cases. So therefore it's recommended to use int32 to be more specific. And this is the default like int sizes that you're commonly used. Now int32 is not 32 bytes, but 32 bits, which essentially is the same as 4 bytes. So float is also 32 bit and it's 4 bytes. Now double is 64 bit and it's 8 bytes in size, so it's double this size. Now in C# you also have decimal, which is even more decimal, which is 128 bytes, and I believe is it 16 bytes then? I'm not quite sure if it's 16 bytes, but it's a large size. We don't have decimal in C++, so we can simply just remove this. But there's a way to, I believe, extend this data size. We also have int16, int8. So we copy this. This is 8-bit, 16-bit. I believe this is 1 byte, and this is 2 bytes. And if you're curious, 1 byte essentially is 8 bits, and 1 bit essentially is either 0 or 1. So essentially this is how computers is working. You either have 1, that means that you have electricity running through your computer components, or you have 0, which means that you don't have any electricity in your computer components. So let's say we have in our RAM memory, we have a value that's going to be let's say 69. So to do this, we need to open our calculator. Then in our calculator over here in Windows, we have programming section, which is pretty nice. So currently we are, as humans, we use the decimal value. Now the computer doesn't use decimal, but it uses binary, which is 0 and 1s. So if I type in 69, you can see our binary value over here. We can copy this. So essentially this is our binary value, which is 1 and 0s, which represent this decimal value. And how to work this out is that if we do 1, I believe so. I'll sometimes forget how which way it works, if it's left to right or right to left. But if we go over here, so I believe it goes right to left. Some go from left to right, so I'm very confused on that part. But essentially, if I can do this, so we go from 1, then 2, then 4, then 8. Just doing this: 16, 32, 84, 28, 25, and so on and so forth. So basically, this is how binary is scaled. If we just do this, yeah, because I have done this a little bit. Oh yeah, I forgot to do that. Then we need to remove this because it's like this. Am I missing? Oh yeah. Let's just do like this. So essentially, this is how the binary is working out. So we have power of 2. So we go from 1, 2, 4, 8, 16, 32, 64, 128, 256, 1024, 2048, 4096, which is 4K, and then you have 16K and 32K and all that kind of stuff. They're basically power 2, right? So the way binary works, it basically just calculates the numbers. So we have 1 here, which is 1. So let's do math here. So 1 plus 1, 1 plus, then we go over here, we have a 4, which this is marked, so 4. Then we have 64. So let's do some math over here. So 4 plus 64 is 68, plus 1, which is 69. That's basically how the computer calculates everything in our computer, essentially. So we calculate everything with decimal. Computer does this by binary. So this is very important how our data sizes are stored. Because if we store, for example, 69, let's do this again. If we store 69, well, the value we are going to use is 64, up to 64. Like the 64 value. Now this means that if we check this, we have 1, 2, 3, 4, 5, 6, 7. 7 bits we are using to store this value. So doesn't make sense to use int 32 because we are storing 4 bytes, meaning 4 additional numbers. Like, so we essentially, if we go do this a little bit better, let's just do let's say yeah, the maximum value, I'm just gonna look it up, 32-bit max. Essentially we come down to this number, 2 million something, right? And we also get, because this is a sign, meaning we can get positive and negative, we have this range as int 32. Now this is very large, only storing 69 in a value. So it would have been smarter to store this as a byte, which is int 8. So to store a value in 69, it would be, for example, let's store like this, int 8. Now, a byte can be either 255, I believe, and 154, I believe. Let's look at this. Oh, sorry. Okay. Okay. Yeah. Sorry. So it's 128 and 127. And this is because 0 is also counted as a number. So we have 128 plus 0, and then we need to do the negative, which is minus 127. So that's why it's not 128 like this. So this is a byte value. Now, a byte doesn't mean much. In this scenario, we can store a value of 69, so this is great. But let's say we wanted to store 255 like this. Then we use an unsigned byte, which is int8 like this, which basically means we do an unsigned byte. Let's do like this. Unsigned byte basically means that we have positive bits. We are only unsigned basically mean we have only positive bits. Sorry, not positive bits, but positive numbers. Therefore, we can store more bits because we don't need to store the negative numbers. We only need to store the positive numbers. So with a byte, we have the range of 128 to minus 127, like so. With an unsigned byte, let's do it like this. We have the range of 255, sorry, from 0 to 255, like this. And you might recognize this pattern, 0 to 255, because this is what RGB is using. So you can define RGB as 255, 255, 255, and we get the color white. And I can showcase this and close this calculator. So if I do X color and do this, so over here you can see there we go. So here we can see RGB, which is 50, and this. So we take this and type in 255, 255, 255. The color is white. If I remove, so we go from red, green, blue. So if I remove the green part, we get purple or magenta. If we remove the blue part, we get red. The 255, and we go from 0 to 255. So that's a very common data type to use to specify something like that. Now we also have another data type, not data type, but a size type, which is a hexadecimal, which is another topic for another time. But essentially, you go from the byte, the numbers. Let's see, yes, gonna look this up right quick. Can actually look at this. If we look at the chart. So essentially, we have decimal, which is how we count. Then the hex is another way to count, which is in compared to binary. So for example, 0 is 0, and then binary is 0. 1 is 1 is 1. So simple as that. But when we come to 10, the problem with 10 is that if we zoom in over here, the problem with 10, the way we count it, is that we basically repeat this pattern. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 essentially is just copying this pattern. So we go 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on and so forth. In hex, we're simply going from 0 to 9, stopping there, then replacing everything else with A, B, C, D, E, and F. And this pattern you might recognize if you use anything to do with coloring or web browser or something like that. Because our hex value, this color, is FCBA03. So let's decode this. So we have this hashtag is just to identify that this is a hexadecimal. So this can be ignored if you don't want to. We can also do capital letter if we wish to. I don't believe it make any difference. Yeah, it will reset everything else. Yeah. So F, C, B, and A over here. So we copy this. Go here, paste it over here, so we keep that in mind. So we go F. Let's do this. So we have okay, so we have F is equal to 15. We do a plus. C is equal to 12 plus B is equal to 11 plus let's see, 8 is equal to 10 plus 0, which is 0, plus 3. So if we zoom this up, well, okay, yeah, we essentially get if we just do this over here, we essentially get this value of 55. Now 55 doesn't matter us to me, matter us in the sense of the color. They might thinking, well, how does this represent as color? If we go to our calculator, type in 51 over here, go to the binary section, this will actually tell how our color will be accessed to, I believe. So we go back over here, remove everything about here. And we type in this. So we essentially go 1. So we have 1 plus 2. We have 4, 8, 16, 32. So this is going to be 51 as well, right? So we have two different systems. Now I forgot how this is actually working. But if we do a hexadecimal to we type in what's this? Essentially, it will decode this value. Let's just see how to decode. Oh yeah, okay. So I forgot how the hex color system is working. So essentially, we do this example again. This is a little bit off topic, but essentially, is grouped by 2. So we do FC as a value. This is our red. We do another 2, which is our green, and do another value, which is our blue. That is how we're doing. So if we do 15 plus C, which is 12, then we do our B, well, our green value, which is B, so 11 plus A, which is 10, and we do our C value, which is 0 plus 3. Essentially, this is how we get our value. So if we go to a hex column and type in this, and is it multiply 15 multiplied by 12? Oh yeah, because I haven't set this. So 52, yeah. So I forgot how to decode again. Decode. The color define, yes. I'm not sure if it's multiplication or it's not addition. Anyway, it basically returns this 15 C 12. C yes. 15 multiplied by 12. It's you this, we're not even close. Maybe it's the different let's just see over here. Let's see math. I hate this that they can't just tell how to do this. The most okay. Okay, so it's 15 multiplied by 16, which gives you this, and then it's follow this multiply this number by 16. Okay. Yes, it is not even close. We are sort of close over here. Then is it like this? 16 then plus. Oh. Oh, okay, I forgot. Okay, so it's 15 multiplied by 16, then plus 12, I believe. Yeah, okay, now I have decoded. I guess now we have the math. Sorry about that. So, so we go 15 multiplied by 16 first, then plus 12. Just to do this as the not pandemas. I'm just gonna use a parenthesis to identify it a little bit better. So we're gonna do 11 multiplied by 16 plus 10 multiplied by 16, which is 0 plus 3. So if I then do this in another term, we get this value. Now the problem is that we are doing this together. We are not supposed to do that together. So we get 252 for the red. And for the green we get 186. And for our blue we get the value 3, which is correct. So that's basically how you can have different approaches for laying out memory. In computer memory, we use this binary number, or the computer uses binary number because it's a very efficient way to do this with electricity. you can either check if the electricity is on or off, basically. Like a lamp. If you have the lamp turned on or the lamp off. If you have the electric cord plugged in or not. Basically, if something is electricity or not. You have this basically example. And if you want to, instead of as a human, we use decimal numbers. So we count 1, 2, 3, 4, 5, 6, 7, and so forth and so forth. And so on and so forth, right? The hex value is basically the middleware between those two. That is something that you want to have a little bit readable for humans, but still at a binary value. Not binary value, but more efficient way to count. So you don't count from 1 to 10 and 10 and beyond, but you use the alphabet instead. So A, B, C, D, E, F. So you can use different use cases for this stuff, but essentially different data types give you different ranges on how you can use them. So this is very important. Yeah, this was a long side topic to come down to constant reference, but essentially when we use f vector over here like this, we're essentially copying x, y, and z. Now x, y, and z is both double. So essentially, if we do x, y, z, essentially is 8 byte plus 8 byte plus 8 byte, which is 16 and 32. So we get 32 bytes of memory. That's a lot of memory. And to just copy this, let's say we're calling this function over here. Let's say that. And then we alter well, we have this as a value type. When then we have a copy, so we have copy once over here as a variable and once over here as a parameter. Then suddenly we have 32 bytes of the same memory value. Well, not the memory value, but the same value, which is a lot. We have them 64 memory in total when we could just half it into 32. So this is a great way to use performance techniques, to just use constant reference, meaning that we are not creating another variable, another copy, but essentially we're reusing our variable memory location, and we are using const to not be able to modify this variable at all. So I will highly recommend to use const reference if you're referencing something. If you want to reference something instead of copying everything, but and the data size, also the data type is having a large values like doubles, for example. So keep that in mind. But sometimes it's not 32 bytes. It's not that much compared to modern day of RAM memory. You can buy most RAM memory is above 8 gig in size today, anyway, in most computers, and most video games is now shifting to 16 gigabytes, right? So you can have 16 gigabytes of memory. That's a lot of memory to spare for a game. So 32 bytes essentially, if we go to Google browser, 32 bytes in gigabytes, essentially is this. It's a very low value. If we do this again, copy this, go to show big numbers online, big calculator, show big number. This and okay. Maybe because this is comma. Okay. Yeah. Can someone just display? No. I don't want this. I want show long numbers. I don't know. There we go. So over here we have. Oh my god. I can't click it. Yes. So over here we have 0.00 sorry 0.0000000032. It's a very low number. So that's basically whoops, if we copy this 32 bytes is equal to 32 this amount of gigabytes. So you can see this is a very low performance hit for the total RAM memory. However, note that the user, the end user, for example the gamer, might have Spotify, YouTube, downloading a game, updating a game, let's say updating an application, streaming a video, streaming a movie on Disney Plus, for example. Disney Plus. Playing a game. Now, the operating system, Windows, for example, allocates every application for let's just do this. Every application gets a sort of a chunk of memory. So let's say 1% of memory. Let's say over here. This gets like, let's say 15. 3. This is just an example. This is not real numbers or anything. I don't know if this gets total to 100%. Let's just see. So let's remove this to 1. We remove 1 over here. We need to remove. Let's remove to 0.5 over here. Let's do this instead. Well, this doesn't really matter. Yeah, let's put this like this then. Let's put this at 10. I mean, add, for example, let's say this is just an example, so it doesn't really matter at this point. There you go. We have 100 over here, right? Consumption. So let's say as an end user, I'm listening to Spotify, I have a open tab for Chrome, which is YouTube, download a game, update an application, like for example Discord for the 100th goddamn time. And I'm streaming a movie on Disney Plus. I'm playing video game. The video game might take a lot of memory consumption, 100%. It was not 100%, but maybe close to that, 80 or 90, maybe 100, depending on what type of game and how much memory you have. But the problem is that once we have gone to 100, now the computer is gonna struggle playing with this game, because if we try to allocate more memory than we have available, some application might go down. For example, if we say we allocate 1 GB of memory, let's say texture files, now we have more memory to we are gonna have more memory. So let's do 16, let's do 17, oops, 17 divided by 16, let's say 4 gigabytes. So let's say 4 gigabyte texture, let's say 4K, that's for reference. That will give 125%, well, 25% more than available. Available. 20% more memory than we have, right? So this is a problem, because now some application is gonna go down because our game requires more memory than we have available. So it's very important to not allocate too much memory for the data type, but in this sense 32 bytes not be much at all. But let's say we have 500,000 bytes. If we convert that, so 5,000 like this to bytes to gigabytes, not bytes to gigabyte, not gigabit, gigabyte. Not, it will not be anything, but let's say 5 million. They still recognize this as wrong. Okay, let's say 5 trillion. So 5 trillion bytes. Let's just do this. Okay. So 5 trillion. Okay. This is million. This is no. Yeah, billion. And this is trillion. Trillion. So 5 trillion bytes will take up equal to 4. The 4 gigabyte, 4.6 gigabyte, right? Now this is an insane amount of memory for a simple struct, right? Simple vector struct, right? But remember that if you allocate and deallocate and allocate memory a lot of times, the memory is gonna cost a little bit of time to deallocate and allocate. But the problem is, if you're using managed memory, for example, let's say this A actor is a managed memory, because this needs to be kept for a lifetime until, for example, this actor gets destroyed by either the game or by someone calling destroy this actor, right? So this is going to be in our managed memory, and therefore it's going to take more memory to save all our variables, for example, and have this memory block alive. So this is going to take a lot of memory. So you can sort of see how a lot of memory can be taken over very quickly when it comes up to saving a lot of stuff. For example, in a scene or a game. The most memory currently, the programming world doesn't because we have a lot of memory as a consumer. We have a lot of memory, RAM memory, 16 gigabytes, and you can see here 32 bytes essentially is just this very low number, right? But when we come down to a video game, if you use 4K texture, that can be quite heavily. One texture can be at 4 gigabytes, so you can definitely see that a lot of video games can be very big nowadays, because let's say we have 140 gigabytes of a video game. There's a lot, there are potentially that a lot of texture is presumably like 50 gigabytes of texture. For example, I don't know the exact number, but also you have meshes and data assets and audio files and all that kind of stuff. Technically, or mostly audio files, script files, all that kind of stuff is compressed. The problem with texture is that you can't compress without losing quality if because if you compress 4K texture, then you're not really having 4K texture. You can have some AI upscaling and all that kind of stuff, which is going to the future, but currently the most memory consumption it will take will be texture files, because there's not really much to compress if you don't want to lose quality, and you don't want to lose quality when it comes to 4K texture. So that's why a lot of memory consumption comes from that. And also you have different techniques. You have, for example, streaming textures, which basically don't allocate well, it doesn't use texture as an asset, but rather streaming the texture file at runtime. And this can be problematic because now this texture file is going to take the memory, RAM memory. This might damage our in-game objects, because this is also taking memory. So that is basically the concept with memory, that you can use different techniques to stream, for example, a world or a texture or shadows and all that kind of stuff, which is great. But the problem is that it needs to store this information somewhere, either on RAM memory, which is the PC component, or VRAM, and I believe it's called SRAM. I'm not entirely sure. Let's Google SRAM versus VRAM. We have DRAM, which is not important right now. This SRAM is DRAM. VRAM is for the graphics card. I'm not sure SRAM, if this is anything to note. I think so. Yeah, anyway. So VRAM is basically your graphics card or GPU. And this has a different memory, like buffer or whatever you want to call pool of memory. So when you're streaming like texture, I don't know 100% of the details, but I presume the texture file doesn't go to RAM memory, but instead goes to VRAM, which has a own memory pool size. So for example, let's say we're running NPCs, we have some collision game objects or actors, we have some vehicle physics, we have some damage physics or destruction physics, we have some networking. Everything this is gonna take on RAM memory, this one. But let's say we have some graphical memory, for example textures, materials, shaders, all that kind of stuff is gonna take on VRAM instead. So this is now you can see most graphics card, I believe GeForce 1000 series, which is gonna be expensive. We don't have a dark mode, great. But yeah, if you look down, where is the information? Yeah, let's just look at this one. So if you look at VRAM over here, video right here. Oh my god. Specification, there we go. So memory size 24 gigabytes. So this has a lot of VRAM. So you can keep that in mind that nowadays graphic cards is increasing the memory consumption. Well, sorry, not memory consumption. Well, that's partially true. But the memory size. So that now video games can stream 4K textures and a lot of graphical stuff instead of having this at the build time or like at the you know, the game files basically. So keep that in mind that memory is very important, on that you want to be as memory beneficial memory performance, but because we are using 32 bytes of f vector, let's say we are using 2 times because we're using value type, we have 64 bytes, which is not that much in compared to a 16 gigabytes of RAM. However, one thing you have to note that is you can still optimize your code, even though it's not going to be a huge difference. You can still optimize. It's the same as if I would type in a text. Let's say I'm just going to copy a text. Lorem ism. I'm just going to generate some text like this. And I'm gonna paste it. Let's just take this a little bit. So we have some text over here, right? But the big difference like between RAM memory is like you can still optimize even though it's not going to be big performance. It's the same concept of adding period. You can basically remove the period over here and the comma and the period again over here, and you will still have text. Now this is just Latin text. It's not readable for everybody because Latin is a dead word. Oh, sorry, dead language. But essentially you can still read words without period, without comma and all that kind of stuff, but we only use period for our own sake to read more. It's more readable and it's more functional by us. It's the same concept with memory. Like you can still you don't have to be very memory consumption nowadays, but it's still a very better way to program as a programmer because you are aware how much memory you are using. Not necessarily exactly how much memory you are using, but you have some knowledge of, oh, I'm using this much memory, and there might be a better way to use const reference rather than just value type. So there's one big side topic for y'all guys over there. Anyway, let's go back to our main file, our main topic. I'm just going to create this example, then I'm going to quit today. But let's just go over about it. So let's go over to int32 over here. So we have alter health. And let's say we're going to alter this health and we're going to remove the const. And we're going to alter this. And we're going to take some damage. We're going to take some random damage. So firstly, I'm going to check if our health, current health, gonna fix this problem. Yeah. So So I'm gonna check if our kernel health is below or equal to 0, then we just return. I like to do this return so I can continue on this level of the branch, because if I would do it differently, if we are above our health, I need to put all our code inside these braces, and the more nested I go, the more indented the code gets, which is very bad code practice. So I like to have the indented at 0, meaning I do the reverse if statement and quickly returning to the 0 indented branch, basically. So kernel health is below 0, we return, because we cannot take more damage. Then we take our damage. Now you can do like this. This is equal to do like this. Minus minus will give you just kernel health is equal to kernel health minus 1. So essentially we are decreasing by 1. But we don't want to decrease by 1. We want to create a random variable or a random value to a decrease. So let's do that. So let's do int32 damage number, for example. Now we're going to do a random value. How do we do that? Well, we have a math class. I believe it's fmath or math. And I'm not sure if this has a random. It does have random rands, and then we have random boolean, and I believe random range, which is range between numbers. And I'm not sure if we have random float. F random, or random float between 0 and 1. Okay. So this is 0 and between random max. Which is this. Now I want a range, so I'm do rand range. And we have double float int 32 and int 64. And this is a larger int value. So over here I'm gonna do between 1 and let's do 500. So let's do 100 between this and 500. I'm not sure if this is inclusive or exclusive between this. This inclusive as well. In some cases, if it exclusive, it means we need to do like this, meaning it's below the max. But because we have below and equal to max, we can use 500 here. So now we have a value between 100 and 500. Right? So now we can do damage number over here. So kernel health is equal to kernel health minus the damage number. Now we can do an if statement over here and check in if our kernel health is below 0 or equal to 0 again. And over here we can mark, for example, we can tell our actor that this actor has died. Let's, for example, call, and this is a global class. We can call, the print function for our game, for example. Now this is a pointer, and when you're using a pointer, you use the arrow operation to access this. You can type in period, and I believe Visual Studio is gonna automatically convert this to an arrow operation. So if I do this, it converts to an arrow operation. So over here, we want to type in add on screen debug message over here. Now we can add some message. I'm just going to do like this. It will require a key, which is a which layers or which depth layer it's going to be added to. So we can add different layers of if it's going to be on top or on bottom or all that kind of stuff. For now, -1. Time to display 5 seconds. Which color? F color. Oops. And we're going to type in, for example, yellow. and now string. Now Unreal Engine uses FString rather than string in C++ doesn't have a string. It has a standard library string, like so. But what I said before, Unreal Engine doesn't have support for standard library stuff, because it has created an own data type for all that kind of stuff. So we have to create a string by using FString like this. And when you're creating a string with Unreal Engine, it's recommended to use a macro to use text. And this ensures that everything string related is converted to a Unicode, from Unicode encoding. So for example, hello, if I type in hello, essentially this macro will just add, I remove this, an L before it. And this essentially means that if, like C++ has encoding from ASCII, I believe, as an ASCII encoding, the default string encoding, but we want to convert this ASCII to Unicode. So therefore we add an L. Now instead of using this, Unreal recommends that we just use the macro to be more identifiable. So now over here we can say you have died, like so. And let's say we destroy this actor. And now here we have some stuff to configure if we want to destroy right away or something else. Now we can just call destroy. And then we can return over here, because now we can also continue from this branch. But if we have died, we stop this branch or this code to be executed, because now we return out from our function. So this is pretty handy. So for example, let's say we are taking damage. Then we can also print that we are taking damage over here. So damage taken. Let's say we want to have a variable over here, or like a parameter to showcase. So over here we do a percentage, and now we can do this is basically the C++ version of I believe it's called sprintf, which is a way to print out a string with data types. So we have percentage, then we have a S for string, F for float, I for int, and D for double, and C for a character or char, whatever you want to call this. But we don't have anything for boolean. So what we need to do is convert this to an I, which is an integer. So this will automatically convert boolean to an int, because a boolean is an int in some cases. So this will be perfect as well. So for example, damage taken, we want an int because we want this damage number. Then we simply need to close this text macro. Then we add a comma and our variable name. And this we can extend this how much we want. So for example, I can do this, this, and this. But note that we need to use this as well over here. Why is it not working? Let's just do this to be more precise. I believe I need to do this. Yeah, I don't know why it's not working. Maybe it's just too much of yeah, I don't know why. Anyway, so we can now send in our variable into our string like this. So damage checking our variable. Let's say we add a plus sign. So it's gonna be like damage taken 100 plus 100, like so. Maybe I like a minus or so. We more identifiable. And let's say we have this at 3 seconds, and let's say red. Let's say green instead, so it is more visible. Green. So now we have our damage taken, all kind of stuff. We can also use other string variables, which is FText and FName. FName is for simple cases to use, for example, in a map, basically a dictionary. It's a sort of key value lookup data type. And we do in C++, we never use the new keyword. New keyword essentially means that we're creating something on the managed heap, meaning in our heap memory, which is very bad because now we need to delete this memory because everything is in C++, everything is manual memory. So you don't want to use a new keyword. This is very important. I forgot to tell you this because this is extremely important for newcomer C++ who are trained in C# because new keyword is very common use. If you want to initialize a variable, you either do parenthesis, which we'll call the constructor. So FName constructor over here, we can essentially add text. And over here, now we have constructed our variable, or we can do assign and do the simple constructor again. Just take more time to type. This is perfectly fine. Sometimes the data type will have an implicit conversion operator at the backend. It's not always this case. Sometimes it can be implicit conversion that the Unreal has implemented, but if you want to be at safe side, you have to use this approach. You also have brace initialization, which I learned quite recently, and this is instead of using an assignment like this, let's say we are using a int32, let's say a, and set this to 10. Let's say a float, let's set it to b and be 10. 10 is an int, and if you use 10.0, it's a double, but it gets converted to an int. This is an implicit by using this assignment operator. Basically, we can assign a different value type, sorry, a different data type to the constructed data type we have used here. So for example, the double would be automatically converted to an integer, and a float variable, I type in 10, which is an int, this will convert it to a data type, right? This is assignment operation, which will do this implicit conversion. If you use a brace initialization, we're basically telling us, do not do this implicit, do this explicit. Sometimes it's working, okay. I believe it's when we compile. I'm not sure if this when we compile, this must be a int. I believe so. So if we just disable this and recompile this code just to make sure. Now we're gonna recompile everything. And sometimes when you recompile C++ code, it might not show up in the blueprint version, or there might be some trouble or some disconnect between blueprint version. So always restart Unreal Engine and restart back up by either opening up without debugging or with the debugger if you wish to. Let's just see what the problem is. Damage. Oh, because we have a actor has already a function called this. So let's just call event take damage, for example. Event take damage. Let's recompile. And we got a compiling error. There we go. Sorry. So we got a compiling error, which is this error. We can search this error up. We can search micro and this error, and we will find this a article about this error, and this tells us exactly what we are doing. So this is explicit conversion. So for example, if we copy this message and just go to our code over here, you can also see if we open back up live coding over here, we also see a numbering the code, the line of code over here. So this is very important if you want to debug something. Let's just zoom in. So you can see here we got a build error, and if we see this error, like just basic error, we can see we haven't got an error. But we also can see over here where we got our error, which file we got. So myactor.cpp. We can see the line of code here, and we can see the error message and the error code. So you can search up the error on the web site if you want to have more details about the error. And you can look at what file and what line. So if I go back to Visual Studio and close this down, I open a file. I can type in or press Ctrl G to go to a line, so 76, and I will go to this line. Now I had a comment before. Let's just remove this 76. And I will get to this line. That's basically it. So we can see here from the message, conversion from double to an int32 requires a narrow conversion. So basically we can't convert a double into int32. We need to be explicit. So therefore we can either do a C style casting, or as you are familiar with in C# we do a casting, which is a C style casting. Now you might have seen in the C++ video we have different casting methods. Now Unreal Engine has its own casting for a responsibility for UObject classes. But if you want to use C++ casting for example data types like int32 and float and all that kind of stuff, we have some couple options. We have static cast, like so. We have dynamic cast, and I believe, let's see, cast I don't know if I can filter this out to be a little bit more specific. We have in let's just see. Okay, dynamic was this brackets. I don't know if I can scope this. That's a little bit shame. Macros in namespace types function. Yeah, a little bit shame I can't specify a keyword. Let's just see online over here. C++ class types. We have const cast and interpret cast. Static cast will do the casting at compile time. So it will check when you compile, it will check the data type and do the conversion directly. If you're using dynamic cast, or I believe C style cast, it will do at runtime. So really check when you're doing the cast at runtime. When you're doing const cast, it's basically just doing cast, but adding the const to your new casted variable. With cast, I'm not 100% sure about it. Yeah, it will basically rechirped. It will basically do a cast, basically convert a different pointer into another different class pointer. It's a little bit complex to explain over here. Essentially over here we can use these two type of cast over here. So instead of doing C style cast, we can do static cast over here and do our variable. So it's going to be int32 or in our data type. And there we go. So now when we compile, this will essentially be replaced altogether. So this is a way faster or handy thing to do. Now the problem or the downside is that we need to type all this long information to cast this double into int32. So depending on what type of casting you want to do, if it's C style casting or static or dynamic casting, that's up to you. The only thing that is great about being more explicit or being more typed is that if you want to look at if you have some casting that is casting issue, you can basically search for static casting and see, oh yes, I'm doing static casting and I'm expecting at compile time to be in int32. Well, for example, let's say I've done double, and when I compile, this gets an error because it doesn't work, you know. So that's basically up to you how you want to do this. And then, like I said, with Unreal Engine, they have their own casting version. So you just type in cast with the uppercase C and then choose another type. So let's say a pawn, which is inheriting from a character, which is then inherit from a U object. I can do a pawn over here as a pointer to a pawn pointer like so. And then we're gonna do this. This essentially is this actor. So we're converting this A actor, or not converting, but we're casting this A actor as a pawn. Now this is dynamic casting. We also have static casting, but I don't recommend it to use this because it's not intended to use as static casting. It's just a implemented weird thing they have done. But we're gonna use dynamic casting for U objects basically. So we are casting a pawn. We're casting this a actor to a pawn. Now this a actor or this class is not inheriting from a pawn. We are only inheriting from a actor. So this cast will fail. And this cast, using just cast over here, will essentially return as a null pointer, meaning it was null. So if we want to use this, we need to check if it's not null. So how do we do that? Well, we do if it's valid. So this is a function, and we can type in our point over here. This will basically do two things. We can look at the source code over here. It will then do convert this pointer into implicit boolean, which is handled at the back end of Unreal Engine. Essentially, we can type in the essential version, which is doing like this. And then we have an and doing this thing over here. So essentially, this is what this function is doing. It checks if it's the pointer is not null pointer, and we're also checking if this has not been garbage collected yet, meaning that our memory memory block is still loaded into memory, and the pointer that is referencing to is not null. For example, let's say in our point over here, we destroy our game object or our actor. The variable or the pointer will still be valid because we have not set this to null. So if we want to be explicit, we can set this pointer variable to null, right? But this is a local variable in this function, so it doesn't really matter. But let's say we have this as a global variable, right? And if we just did this pawn pointer, so essentially it will be converted into this because it's an implicit conversion from pointer to a boolean. So if we just did this, then let's say over down here instead is pawn pointer, because and we remove this because we have destroyed our pointer that is now destroyed. It's now marked as garbage collected, but this can happen at any time, and this pointer might still be alive because we have not set this as a null pointer over here. So the pointer might be still alive. Well, it's not a null pointer, but basically the pointer is not null, so this will be valid. But a pointer that's referencing this a actor or this a pawn has been marked for destruction, basically marked to unload its memory. So when we try to access this pointer, we're gonna get a crash. Let's say let's just call it a function, random function. So essentially, this pointer will have, basically this will crash because when accessing a pointer that's still alive but is marked as destruction, therefore we can't basically sometime this pawn will not be existing anymore, but the pointer is still alive, and when calling this, our pawn has been destroyed, our pointer is still alive. So that's the problem, that we want to use is valid rather than just doing if statement without using is valid. So this is very important, that you want to check if the pointer is not null and is not marked for destruction, so we can use our code later on. So that's a very important thing to use with is valid and all that kind of stuff. Now we also have another version of cast, which is cast checked, like this. And this basically checks doing assertion and say if this check if this cast was not successful, crash over here. And this is a great way if you want to make sure that this cast must work. If not, then we're just gonna crash and say, and then we're gonna tell the program, hey, this cast must work at all time. This is a great way. And you can also use assertion. You have three assertion. You have what's it called, check, verify, and ensure. Check will do both. All these assertion will do boolean as a condition, so you can type in over here false, both things. And for example, in the check, if the condition is false, will it crash the program. So you can use this for example, a variable as a pointer. If the pointer is new, then we're gonna crash our game. We can also do is valid to check if the pointer is also marked as destruction. Then it's not valid, then we're gonna crash the game, basically. Now these three assertion is a little bit different. I can't remember exactly, but if we search for Unreal Engine assertion, essentially we have a check. We also have a slow version, which is gonna take a little bit more performance. But we have then check is member in that member of the first family halt execution when the first parameter evaluates to false value, and do not run in the shipping bills by default. So that is interesting. Verify is similar to check. However, verify macros evaluate their expression even in builds when the checking macro are disabled. So for example, you can use this in build files when you have shipped game. You have ensure, which is similar to verify family, but works with non-fatal errors. For example, you don't want to crash a game, but you still want to have a assertion basically telling the programmer, hey, this should generally not happen. So essentially, check if you want to crash the program or the game. Verify if you want to crash the program in the PL file. So build, non-build, crash. Just to give you a simple one. Build, non-crash. So essentially, this is it. So you have non-build, crash, build, crash, build, but non-crash. And then you also have ensure always, because this is trigger once. So if you wanna just for example, let's say we are let's say we are creating a variable over here. I'm better to, let's say, player health, and it's supposed to be at 1000. So let's do player health equal 1000. If the first time this is false, it will then trigger for example, a error message saying, hey, this is not expected. But the second time we start to play the game, or in our editor or in our game file, this will not trigger at all. But if we use ensure always, they will trigger every time we start to play. So that's keep in mind that when you use an ensure, it only trigger once, but if you use ensure always, it trigger every time you play. But it doesn't crash the game. It just tells you, hey, there's an error, fix it, basically. Now I like to use check because if it's not intended to be null or false, for example, this is currently going to be false because we can't cast to a different data type if it's not inheriting from it. But let's say this class should not be, this pointer basically should not be null, and if it is null, then something has gone horribly wrong. So this is a great way to basically ensure, sorry for using that macro, but basically make sure that everything is working fine. You also have other couple alterations, or like alternatives, which is check F. And this basically gives you some message, and you can also use arguments. So like then over here, a boolean over here. So you can say in the crash report what exactly happened. For example, let's say this should not happen at all, and when the happen at all, and when the game crash, you will basically see this error message alongside with the line of code as well. So that's very important that you have that. You also have for the other assertion as well. You have verify if and ensure. This is a little bit different. Message if and ensure always message if. It's a little bit different from the rest, which is with, but it works. So for example over here, text. I'm just gonna copy this over here, like so. But that's how you can use Assertion to verify that everything is working fine and there's no bugs in your code. So let's go back to the string. I'm just gonna go over this really quick. Sorry for being so long live stream. But FName is basically for key values, basically. So for example, username is a perfect example. This data type is case insensitive, so I can basically do this and do if whoops, I don't know if I can do this, or I need to do equal. And I can do this, and this will work perfectly. So this is gonna be converted, I believe, into like this, lowercase or whatever. So it doesn't store. By default, you can ignore the case, but you can also choose if you want to change this. So it's gonna be case sensitive or ignore case. By default, it's gonna ignore the case sensitivity. But that's very great to. It's also lightweight and fast to use. So basically, if you want to use lightweight for text, for not text but string, for key values and like short stuff, then use FName. Then we do FText, which I'm gonna get later on, and then we have FString. FString is gonna take the most memory. Therefore, it's recommended to use in this order. Like if you're gonna use something short, use FName. If you're gonna use something that's gonna be used for the UI side, which I'm gonna explain in short, then use FText. And if you want to have some other string manipulation, like splitting the text or replacing or appending, converting, contains, empty, ends with, and all that kind of stuff, and I have FString. The last thing I'm gonna go about is FText. What is FText? FText is primarily used for the UI side. If you want to have a text with some I don't know how to say, internationalization, basically translation, essentially. So to create an FText in with C++, you can use FText. This basically creates a culture in variant, and basically use a text macro. You don't need to use like this. You simply can just double quote like this and say hello, Essentially, it will create a text, FText based on this. So FText is used for translation, but because we are not translating anything, we can create an empty FText with no translation at all. We can basically create this for UI sake, right? And if we want to create this FText with translation, we can search up over here. Over here. So for example, over here we have FText, which basically defines a namespace for our translation. Then we have our text to translate. This could either be adding some like variable, not variable, but argument formats. So you have this kind of format. You can also search for Unreal Engine FText format, and you'll find a community post which help you how to do format FText a little bit better. Now this is a return value, so you need to keep that in mind. Essentially, you have FText, the function, which is format. You need to have a namespace or a key, and then you have the text, and then you have the format. Sorry, the variables you want to have as an argument for this function. So that's one way you can do it. You can be a little bit better about how to format everything. You have F format name arguments, which is just args. Now you can add the arguments you want to add. You want to use the key that you want to replace it with, and then you have the value. The for example, name is going to look at key, so we have this key, and it's going to replace the key with this value over here. And that's basically how you can format with a little bit more style to it. And the last thing is that if you want to have inline formats, so you have F6 for format name, our translation, and then we have our inline formats over here. So that's one way to do. And then FText over here. We get this code. You have this. So if we zoom out a little bit, and we can remove this, and we're just gonna do this a little bit better. Okay. We can just say FText over here. Well. We also need to add semicolon over here. That's a little bit annoying. And that's a little bit annoying. That is sticking to the window. But basically, we're defining a namespace. Okay, so this is basically just defining a namespace for our translation to be existing on. And this is only valid for one single file. You need to redefine this namespace where you want to use this translation. Then you add the translation macro, which is nslock_text, which creates a string each rows with pass through the localization system. So basically translation. So create a namespace for the translation. You have the keyword for the key you want to translate, and then you have the default value, I believe. I believe basically it will look up either store and I'm not entirely 100% sure what is happening because it is creating a new, is either replacing or having a default value. Anyway, then we have this text which presumably takes the key from our namespace, and then I assume also here a default value. Yeah, default value, and then we're gonna replace this. So this is basically how you can do it. So we can have, for example, new game text over here, and then we're having, for example, in Swedish, needs to be here, for example, and then in our UI side we can then translate if we want to have to Swedish, English, Germany, Danish, English, whatever you want to have it. But that's way handy stuff you want to do with FText. So FText for UI, FName for simple cases, and FString for the rest of the things. Anyway, I've done a lot of things, so I just want to compile this code and showcase in Blueprint, and then we're pretty much done today. So I'm gonna recompile and just showcase this. I've been live streaming for 4 hours, so I'm pretty hungry right now. I'm gonna end this in a couple minutes. Maybe I'm gonna pick this up in another day. Let's see. So over here I'm gonna create a class that we have created. So you can go to our blueprint section over here. And we have common classes, but we want all the classes, and we want to search for my actor class, which is this one. You can click on this. We can have a prefix or BP, short for blueprint, underscore our name, so my actor, like so. You can also see in our, it's very hard to see with this tool, but information about this blueprint, where the class is defined and all that kind of stuff. We can also see in the content browser, we have content, but we also have C++ class. We can see a module class, and we can see on a public section we have an actor, and we can double click it to open up in Visual Studio, which automatically open this up. You can also see in our module the different this is the default classes that have been created by this template. Essentially we have some C++ classes. We can also double click it to open up and see all that kind of information about that. That's a great way to do it. Anyway, so now we have created my blueprint actor. We can now call our function definition over here. I'm just going to remove this over here. Save this. So I'm going to create a variable. Call this. No, I'm not actually. What I'm just going to do is save this. And we can see in our details section over here. We have max health player. We can set over here, and we can also drag this to either one or value. So we can set it to the max value, which is 1000. We can set it 800 also. So that's been handy. And if I were to do get health over here, we have a call function, and we also have a variable over here, which is exposed, both in the editor and the blueprint. If I call the function, this will then not have an execution pin. If I try to use take damage function, you can see we have an execution pin. This does not have. This is because if I only have an event, for example, on a BeginPlay, I can hook this up over here, and then the flow will continue on this side over here. But because of our blueprint pure, we don't have an execution. This just have a return value. But this is more meant as a getter, as a continuation flow. If that makes sense. But for example, we can now say, so we are now calling, we have a stuff over here. I forgot to expose this, so let's just do that. Now sometimes Unreal Engine and the blueprint, when you modify C++ code, it's not optimal to have the blueprint version open up at the same time as you doing live coding. So keep that in mind when you're recompiling that. Make sure to close every blueprint window that you're gonna recompile, because sometimes it can cause some issues. Sometimes it doesn't, sometimes it does. Keep that in mind. As you can see over here, now we have a variable called speed over here, and we have the default value of 8 kilometer per hour. We can also type in the value. So let's say 200 centimeter per second, and then automatically convert this to 7 kilometer per hour. So this is pretty nice. So I can say 16 meter per second. 16 meter per second, which is 76. I believe it's. This is almost 60 kilometer per hour. But this is pretty handy. So yeah, that's basically the blueprint, or like the editor side. Now we have blueprints. Now we can do get and set our variable over here, which is pretty handy. So this is because we have been blueprint read and write. We can also read from this, so get speed as a blueprint pure, but we also can modify this as an execution pin. So keep that in mind. So let's say we want to take a damage. So in our over here, let's say we want to add this to a well. You now see that we have a default over here that we can call this function. So now we can take damage because we in our function we added the call in editor over here. So now we can take damage. Now I'm not entirely sure if you can do this with parameters. I don't think you can do with reference parameter or out parameter, which we will see in a second. If I start play this game and I go back to our actor over here, I can now click on this, and now we'll have this. It's not showing up correctly, which is interesting. Whoops. I need to recompile this. Why it's not doing that? Oh yeah, this is because by default the FString doesn't do this, and we need to do printf over here. This is basically as printf in C++, regular C++. So keep that in mind, that printf. So this we don't have any arguments, so we don't care about it. Whoops. Compile. Like so. Then we can do this again. So we click on our blueprint, on our function, and we can see we're taking damage over here, and now you have died and the actor had disappeared from our scene or from our level. But that's pretty handy and cool. We can also do an alteration. Let's say begin play. We're gonna get our health. I'm gonna print out to our console or to our display, to our window, game window, like so. We can use print text instead, because now we can format this. Let's say health equal that, like so. Like so. Now what I'm gonna just do is just convert this to a function. So I can do print health over here. So I don't need to duplicate this code everywhere. So over here we print our health. Then we can alter our health. Now here you can see our pin connection for our health. It's not in, but rather out. So now we can see our return value over here. And this is very important because now we just do this stuff over here. We say alter. And we can do this. You can see now health 0 alter if we increase the time. You can see now alter is 69. Health is now before 0. Alter is now 69. So that's a great way to do this, to get a out parameter. Now if we had a reference parameter, but we don't want this to be const, we don't want to mark this as const, because making it const will make this a reference as an in parameter. We save this, then remove this for the sake, save and recompile. So let's see how this does it. And we have that, because yeah, you can modify it, of course. And there we go. So now if we check our blueprint again, and we try to call alter health, now this will reference as an in parameter. So that's a great way to do this. Well, let's say we want to have a reference, but we don't want to have this const. How do we do this as an in parameter? Well, you have you param lives call, which is another macro that you can call. We can use this, no, we cannot use this macro generator, so I need to search this up. Okay. The you ben UI you and over here we have all this specifier. We can see ref. So if we use do param and ref over here, and it will now tell us to, instead of using out parameter as in parameter, without making it const, like so. issue. Oh, we didn't save the CPP file. Oh, great. And we compile. There we go. Let's clear this up. And then we do auto health. And as you can see here, we are passing this as an in parameter instead of an out parameter. Now notice that this is an ref parameter. That means that we can't do, as you see here before, without ref, we're passing as a value type. Therefore, we can mark this in this node. Because this is a ref, we need to reference something that already exists. Now in Blueprint, you have also make literal, which basically means that you can create a temporary variable at any time instead of having a variable in the details or the Blueprint section. But this is a sort of a shady way to do a reference, converting a value to reference. But that's basically it with blueprints and C++. Now I can go into further detail with some complex topics, such as if you look at it over here, which is this document that I wrote. You have a little bit more details about some stuff. Everything is working, collections. Yeah, I haven't touched on the collection that we have. T array, T map, T set, all that kind of stuff. We have some pointers, small pointers, which I'm not going over today. We had touched on value type and reference type. And yeah, but there's a lot of stuff to learn about. So I highly recommend that you check this. Check this out. I can also do is click on share, get a QR code, and there we go. If you want to check this article, scan this QR code, and you'll bring up to this GitHub page, which you can read a lot about Unreal Engine and C++. For example, if you want to learn more about C++, you can click on this section, go over here, for example, polymorphism, color braces, semicolons, comments, multi-line comments, standard library, native types, modifiers, type diffs, accessibility, mutable and friend keyword, switch cases loops. Yeah, that's another thing that I can go really quick about. There are different loops in C++. In C# you have for each var, for example, let's say int number in numbers. You do like that. In C++, it's sort of similar but a little different. Let's just do multi-line comment over here. So in C++ is you do like this for. Let's zoom in. You do for the variable name, the variable type. So int name, then colon, and then the array, whatever you're looping through. That's basically it. So there's sort of the same syntax and the same concept. Note that this, because this is a value type, by default, not by default, but in this scenario in C#, everything converts to reference type. I'm not sure in for each loop or something like that. I believe it's determined by the compiler in C#, I believe. I'm not sure, don't quote me on that. But because everything in C++ is value type, you need to be explicitly about this, not to be a value type. Basically, do not copy every time you're trying to loop through an array. Just use the array number that already exists, or like the array element that already exists. So this is how you sort of type the for each loop. And then you have a regular loop. So int, note that you want to use int32, as I said before. So I this length, let's say 10, and I++, like so. You can also do plus I. Some say this is a greater performance, and is more greater performance, but is slight minimum performance benefits. But that's basically one hack to gain some small performance. Then you also have while loop, which is just if this condition is true, then do the while loop. You also have do with while, and this will basically you can do something before a while loop triggers. So for example, if this for example check if we can do, for example, like this, if it's valid, then return, then we say destroy. So sorry, if this is not valid, then we return. But if we are valid, then we can destroy ourselves, right? But this does yeah, I'm like, it's a little bit hard to explain, but basically we do this before we check the while function. But if this has not met the condition, if it is still true, this while condition, I believe this is going to be looping as well. Not entirely 100% true, but you have some different loops to work around with. So that's basically I'm not gonna go inside so much on async stuff because it's more complex with C++. But you have like polymorphism, recursion, linker, and about how to work with linker and the DDL, file formats, lambda, how to use that, binary code, all that kind of stuff. And some video links and image to learn, and some design patterns, hierarchies, solid principle, singleton pattern, all that kind of stuff. And then you have some data structure, so you have array list, queue, hash set, dictionary, linked list, time complexity. That's very important when you're working with data structure, that you don't want to use something that's going to take a long time to compute. So for example, a bubble sort is going to take a longer time than just a more optimized sorting system, so keep that in mind. But that's basically it. So I highly recommend that you read this documentation and read some comments from Reddit, YouTube, Twitter, or X, whatever they want to call it now. Essentially gain more information, watch a lot of tutorials, read comments, post comments, post like a question to forums and get some helpful answer. And I hope you will enjoy your journey. Little bit sad what happened to Unity, but I'm still like sort of angry, but also I will not say I'm happy, but more so like Unity has been shitty for a couple of years now, and I'm glad, sort of glad, that more people finally noticing that this behavior that they are doing is disgusting and very horrible for both the customers and the people making the games. So it's very disappointing to see that Unity is not actually caring at all for developers. But they sort of say they care, but who knows really. The trust is already broken, so if they like, many developers is gonna be changing anyway. So I hope this live stream has been helpful. If it has, then please give a like and subscribe to this channel. I'm gonna make shorter content based on learning Unreal Engine, which has been for development in, I believe, from February, which has been a long time. It's almost October, almost end of the year, so I'm not sure if we're gonna finish. The reason why is I had to do a lot of retakes, reshoot, not been motivated to do that video. Then I have some university projects and assignment that I need to do. I don't have a lot of time now actually, so that's why I'm done this live stream, just to get something out, to get something that everyone can understand and help in this video. So yeah, thank you for watching. I will see you in another, either in a live stream or a video. And if not, then please check out my GitHub. I'm posting a lot of stuff on there. Also check out my Twitter or X to see some new stuff, and on Instagram as well. I post a lot of cool stuff over there I can showcase. If I go, let's see. Yeah, my Instagram, I'm doing a lot of music, GitHub stuff, doing a fun game I've been working on a couple of days. So yeah, a lot of stuff to do. You can see some cat pics if you want to. But yeah, I'm gonna post a lot of stuff on GitHub, and I'm working on university and a lot of about web development. So that's a niche new thing that I've been learning about. So yeah, anyway, thank you for watching, and I will see you later. Bye bye.